the basics. The basic means we are here to learn the plumbing designing, right? So now plumbing again is a part of a building service, isn't it, everyone? It might be any kind of building. It might be a kind of, I can say, industrial, commercial, residential, isn't it? Building is a building. It might be of any kind of application. It might be commercial or residential or industrial. But this is some basic things over here, which we call as a building services, or we known as MEP services. So what do you mean by this? Now you have heard this term MEP service or MEP thing. Now MEP stands for mechanical, electrical, plumbing. So now under mechanical comes as HVAC, and MEP stands for mechanical, electrical, plumbing. So under mechanical comes as two things or the two services. One is HVAC and firefighting, and second is E, that is electrical service, and third is plumbing service. So now these are the major service I'm talking about. It's not something that these three services will combine a building, or this three service, if it's been installed in a building that is a habitable for humans, I mean a good place to live for. No, because there are a number of services which makes a house or a residential or commercial or application like industrial easy or convenience for the human beings as per the application of the project. For example, if I'm dealing with a residential, I need is plumbing, I need is in case of fire, I need some, at least I need what portable fire extinguishers. If I'm not dealing with the, I mean that diagram of the tree and all this, so at least I need portable. So again, firefighting comes into picture, and without lighting, we could not imagine, and without air conditioning again, because of the temperatures growing again day by day or year by year, it's been because of global warming, I can say it's increasing like anything. So we are having this as basic services as of now. But apart from this, we are having a number of services, like I can say, if it's a high-rise building, we do have lifts into that, elevators or escalators in short, yes or no? We do have steps. These are all what one more services like furniture layout or furniture. These are all services. So these are all combined makes a building complete, and it makes a good place to live in for humans, or it makes convenience or ease of the human beings to work or to live in that particular area, yes or no? So now what we are learning among MEP right now, we are learning is partly M and complete P. So that partly M is we are dealing with HVAC, firefighting and plumbing again. So that is we are dealing with partly M and complete P. That is again plumbing and firefighting. So now who will be gonna taking care of this? We'll be seeing this, but let's have some more information about this. Now these three are technical fields which covers the system to make a building habitable for humans. What do you mean by habitable online? Good enough to live, in short, okay, or convenience to of humans, okay. So this, now MEP installations are normally designed. Now don't fix to installation, because unless and until there is no design, there is no installation, yes or no? So first of all, this things MEP complete would be a design and a combination. That means, for example, there will be three design engineers. One would be taken care for HVAC, one would be taken care for electrical, one would be taken care for plumbing and firefighting. So they do design on the same project, because architecture layout is the same. On that architecture layout, the designing is being done for the plumbing, on the firefighting, electrical and HVAC, isn't it? So now this all things would be designed in a particular at the same time. The reason behind that is what? It requires a coordination. If you don't coordinate, like example, I have allotted some space, for example, like let's think we are in plumbing and I need some space on the ground level to keep my water tank, just an example online. But someone said, no, they want to keep something like water cooled chillers over there for HVAC people. So we need a coordination. For example, if I'm keeping overhead tank on the top, okay, that is roof tank, okay. But I got some information from the electrical, no, that space what you have selected, I have already occupied for the solar panels, just an example online. So what? It's a major and hectic task. So we need not only the design at the same time, we need to sit and we need to have a kind of conversation or coordination work or coordination, so that to avoid all the circumstances or this kinds of clashes into this. Okay, so the same thing has been mentioned over here. Due to the high degree of interaction between them, this combined approach also prevents equipment location. Now equipment refers to the machines. It might be for plumbing like pumps, it might be for I can say tanks, or it might be in HVAC like what shall I say, chill electric this water cooled or air cooled chillers or number of things like ductable split or XYZ outdoor units and all this. If you talk about again electrical, like if is going with a transformer complete for this his location, I mean the project, then again this needs to be also be set up. Okay, so location conflicts was being done because we have set and decided, okay, then clashes are a common problem when mechanical, electrical, and plumbing systems are designed in isolation. That means if without coordination, if I'm designing, it is highly impossible to do up. I mean, what? The installation in actual practice. Why? Because there is no coordination. And as per my mind, I have done the designing. As per his mind, he have done the designing. But there would be certain things over there that at the same time what we have selected for the space for our units or our equipment or the routing, whatever it might be some other service people also have selected. Then if there's no coordination, then it will be highly impossible to do up. Even though if we do with the coordination also, again we'll be having issues as per the site conditions. Yes or no online? Hmm? So now let's go on with this. So this is just some basic idea because we need to know that where exactly we are falling by. Like, so we are in MEP services, that is also known as MEP services or building services. So, but just for your information, not only this service, like if I'm having in a building, regardless of the application, whatever the application it might be, regardless of application, if I'm having these three services, I can't say that a building is a building or it is like a habitable area for humans. No, because there's not only three service which combines or which I can say it's a complete building, because there's not only the three services, I'm having n number of services in the building, isn't it? So they are listed by, but what is the reason behind that it is be given priority? The reason behind this, an MEP is given so much a priority because this is the biggest service among all services in the building services. I mean, I'm talking about the building services, not about the building. Building is complete, including of all services. Yes or no? I'm talking about this. So what I'm saying is this is the biggest service of all the services. So what are the services? We'll be seeing they are listed below, and who is applicable for what kind of service and what engineer will be taken care for this XYZ services we'll be seeing. So now let's move on with the very first service. So HVAC service. Now it might be design, installation, estimation, whatever it might be. So basically again, HVAC, a mechanical graduate is eligible to work with, or he is the person who can design, or he can install, or he can do the estimation and the commissioning, tab work and all this. Basically what I mean to say is we need a mechanical background, a master's degree or a bachelor's degree to work with this HVAC service. So basically again, HVAC engineer is being required to work out with HVAC service. Next is electrical. So electrical means electronics or electrical online. Who is the one person who takes care for this? Like the lighting load calculation, the routing of the cable trays and the routing of the cables and all this, and giving the connections to the power circuits. Anyone?
Electrical engineers.
Electrical communication.
Electrical communication and electrical.
Not communication, triple E. Electronics and triple E people. Okay, so triple E people will be dealing with electrical, not electronics. Electronics is different. Electrical people will be taking. So here we require an electrical background engineer, okay, who is having a master's or a graduation degree in electrical engineering. Okay, so he is the one, he can deal up with the installation, design, or whatever it might be, he can deal up with. Now third is firefighting. Again, a mechanical engineer has been required to execute or to design. Fourth, again, a plumbing, that is again a mechanical engineer has been required. So basically I can say if you are from mechanical background, you need to do is HVAC and plumbing and firefighting. Firstly, because this is a core courses, or this is the main gist you can say of a mechanical background if you are entering into the MEP service. Lastly, you put it to electrical. We need to do that electrical also, because when we move on with the senior position, so company looks for a person who does all the services so that they can save some cost, and there is one engineer who is looking for complete MEP service, isn't it? Or else three different engineers they need to hire, one for plumbing, fire, one for electrical, one for HVAC. So that's best if you learn this all three. Next is elevators or escalators. Now, what do you mean by elevators or escalators? Now, you might be getting a confusion that is being done by architect or the civil layout. Architect is a person who gives you a layout, and civil people is the people who does the execution like brickworks and all this, right? But these things we need to install, and that where we need to install in the architecture layout. You can see a lift well or elevator well or escalator well. That is nothing but a space given in the high-rise building so that you can place the lift so that in that shaft the lift can go up and come down. Again, that has been provided from an architect at the time of the architect when he's preparing the layout for respective building, isn't it? Yes or no, online?
Yes,
Online?
sir.
But again, for this load calculation, that means based on the length, width, how much the lift is being left and the number of people. Again, this has been again calculated by again some design engineer. But who is responsible for this? What kind of
Electrical.
which one?
Electrical, triple E. Triple E,
No,
electrical.
this is purely mechanical. I'm not talking about the connections. I'm talking about the installation and the design. How much capacity, which company to be selected. They'll be doing based on their experiences. Okay, for this much length, width, and height, how much capacity it can hold by. They have some building parameters. They just take from the architect or the main contractor, and they deal up with this. Okay, and once they have done, so this is again a purely mechanical side. So mechanical engineers, they recommend that okay, you need to go with this size and you need to go with this company and you need to go with this kind of elevators in your project or the lift over here. Okay, next is solar. So solar again is taken care by everyone. Nowadays you can see solar panels also installed on the roadside, like the traffic for this lights and all this. So again, who's taken care by solar? Anyone has any idea? Mechanical and partly electrical. Very good, because this both engineers can work. Okay, because this is combination of both. So partly mechanical and partly electrical engineers both can work and do the installation or the design for this. Gas system again is a complete mechanical background required. Security system deals with this cameras and all this. So what do you people think? Who deal with this? Security systems, ECE?
Electrical and electronic communication.
Yes, so I can say ECE people, right? Electrical, not electronics. Sorry, not electrical, electronics.
Electronics.
Sorry, electronics. Okay, electrical is for this electrical service, like the lighting, load calculation, all this, that is electrical. Here, CCTV cameras and all this, so electronics and telecommunication also can be used over here. Next is the BMS system. So BMS stands for Building Management System. I think you know this. What is Building Management System? Again, we have a one more service inside the project, that is Building Management System, that all the things has been linked to one software. That example, if somewhere is a problem, I'll get to rectify it by means of a software, so that I need not waste my time to rectify where exactly the problem and what is the problem. Okay, I get the information based on this software. So this is again being done by partly instrumentation and partly electronics. Okay.
Mechanical.
No. Mechanical, no. Might be in some cases they are in worst case sizes, but this is specialized. I'm saying yes. Specialized means it is preferable for all this. In case, for example, someone went on vacation and all this, if he's taking care, if he has an idea, then they can. But I'm saying you specialize. Like example, we have done our mechanical engineering mostly. And what is our specialization means? We can say that, yes, I'm specialized in MEP service. Isn't it online? Yes or no? So that's what are they specialized with respect to their backgrounds? I'm saying these are the engineers who is preferable for these kind of services. So these are number of services over here which makes a building again, which is installed into the building for the convenience or the application for the humans. Not only this, there are small services, like I can say one more is a furniture service, like example, in which you'll be getting the details of the doors and all this. And you can see one more masonry is one more service, that you need to know how much concrete is to be done or the cement plaster is to be done, half inch or whatever, internal and external. Yes or no? There are number of services I can say. If I say there are very long services, like example, I said na, furniture is one, mason is one, and there are I can say this height of the slabs and all this is one more, structure is there. Yes or no? So there are a number of services. So we are not into this all. Why I'm saying you so? Because this complete all the services what I'm talking about is somewhat major services, but among this all major service, the biggest service is MEP. Why biggest service? Because you know this is complete HVAC. Among this MEP, HVAC is the vast service. Yes or no? So the biggest service means it will have a good amount also. Yes or no, online? Do people believe this or no? Amount also, that means for the installation. So that's why it is given a huge priority for this. So these are the services, I mean, which makes a complete building. Not exactly I can say, because there are n number of services, but just an overview, right? What we are doing and where we are and what are the things which which is given essential or importance in this MEP services, and what are the different services which has a convenience for the humans. Okay, so this was about some just information or basic idea about what we are doing it over here in the engineering and MEP service in this application engineering over here. So now introduction to the plumbing. So this very first thing, let's deal with the very first definition, what we are about to see and what we are about waiting to learn for. So what is plumbing? So I can say one thing in short and sweet and easy manner. Plumbing is a system or any system which so this very first thing, let's deal with the very first definition, what we are about to see and what we are about waiting to learn for. So what is plumbing? So I can say one thing in short and sweet and easy manner. Plumbing is a system or any system which can be used to convey the fluid in wide range of applications. Now, it's something which is used to convey the fluid. Now it might be water or it might be something. Okay, it's a fluid. Convey the fluids for a wide range of applications. You can take for irrigation, you take for industrial, you take for commercial, you take for residential, a number of applications. Okay, so everywhere I can say in short, plumbing is nothing but a system in which we are using to convey the fluid to any kind of application. Okay, that's what I said, a number of applications. Like in residential also, we do need as what the fluid is a medium as water, okay, for human things to be done. For example, like having shower and drinking of the water, cleaning house, washing the utensils, XYZ. For example, if you talk about any commercial buildings, if it's again a commercial building, again it might require for the flushing of the WCs and again laboratories and all this. If again it's a hotel, then again it needs some wet area in the toilet area or the bathroom area over there. If it's again industrial for the food processing or something, again we need over there. Yes or no? Or if it's some again thing, any kind of application like irrigation, again we need the water as a fluid just to do the watering to that XYZ irrigation or the plantation over there. Yes or no? Online. So in simple words, plumbing is something as which it's used just for the convenience for or to supply of the fluid or water, you can say, to any kind of the application of the ranges, you can say. Next is what is a system? So we got, okay, plumbing is something, we got an information. Now what is a plumbing system? Plumbing system is something which includes of like the installation or with combination of all the materials over here. Like I can say in plumbing, we generally sees or tanks. It might be overhead tank or underground tank. Okay, first thing we might have pumps installed with the tanks, and we might have piping connected to that pumps so that the water pumps from one place to another. And to that we have number of fittings and accessories like elbow T, reducers, valves, everything. Completely, if I combine all this, I can say this is a plumbing system. Okay, the same thing is given over here. What is exactly a plumbing system? A plumbing system is used by combination. This is actually, you can combine a club, pipes, valves, plumbing fixtures, tanks, and other apparatus to convey the fluid. That means transfer the fluid one place to another. Piping is just a medium, you can say, to transfer the water one place to another, but change the direction, all this, again, that also takes very important essential role into this. Then that is done by fittings. And again, accessories, for example, I need to stop water in some line, or example, in some XYZ toilet. So I need to have a ball valve or an IV over there, isolation valve, right? So these is a plumbing system, I can say, combination of this, I can say, as a plumbing system. So I hope that's clear, everyone. If you have any kind of doubts, you can please come back to me, or you can share your knowledge, or you want to ask something, you can. You're free. You feel free to ask anyone. Is that okay? Shall I proceed, or you have anything? Please come back to me right now. Is that clear, everyone?
Yes, sir. Yes, sir.
Okay. So this was about what is plumbing and what is a plumbing system. I'll show you an image also. So you get an idea. You can say this as a plumbing system. Just try to recall online just what we have read. I'll say you, for example, these are the two pictures over here, and this is WC and this is a laboratory. That is nothing but, I can say in general words, because right now we are learning, was basin, but in technical term, I'll say as laboratory. And this is WC. We'll be seeing the categories also. So now from this WC, you know, the moment we flush, the water goes collected from this pipe and it goes like this. Okay. And again, if he drains out the water, what he's collecting, the skid, if he throws this, it goes all the way, passes through this P trap, and again it goes down, and again it is connecting into the same pipe from where the waste is coming from this WC. And from this you can see it is going with some slope, and if it's going and connecting to this pipe. So this is, I can say, as a stack, the riser or the stack, and this is directly connected from this WC, and this is directly connected from the what? This is from the laboratory. So, but there is a huge difference between this pipe and this pipe. This pipe is called as waste pipe. This pipe is called as online soil pipe. Yes,
Soil pipe.
Okay.
Yes,
so
yes.
If you see over here, there are different kinds of pipings over here. Like I said, what's plumbing system? It's not only just the conveyance of the fluid, that is only plumbing, but system is something you can see. For example, I'm having this amount of only, like example, half meter of the pipe of XYZ material, and I need a turning. So I'm having one elbow, 45 degrees or 90 degrees online. What is this?
90 degree.
This is 90 degree.
Okay. Then again, I'm having one piece over here, again 45 degree elbow, and one more T over here.
45.
Why I have left?
Why T?
Yes. Why I have left one T over here? Can anyone say me?
It is for a drainage.
For the vent.
Why I have having T over here? Yes, because I can have one flow drain over here.
For the vent.
Flow drain. No, not vent. This is flow drain. For example, if some water is being over here, so it needs to be drained out. Nah. That's why we are leaving one option, so that the water collected into this and it can go into the same pipe. So this is again this thing. So what I'm trying to say here is this is a system of the piping. That is, it's a system. So in system, we might see this are the fittings like 45 degree elbow, 90 degree as a T, a number of things over here having. Okay. And after this, we are having is what? This is fittings over here. Again, you can say fittings we'll be discussing now. This is again a P trap. Again, one more kind of fitting, which creates a water seal. Don't get confused. I'm just saying we'll be discussing this is much in later. I'm trying to say you what exactly is a plumbing system. So plumbing system, again, this is a combination of this, and this is called as a waste line or the wastewater line. And apart from this, this pipe, which is going above, this is called as a vent pipe. Okay. From here, all the gases, because it is connected to this. So what happens, the gases from this and the gases in this, the water is heavy when compared with air. So water comes down by means of gravity and by means of slope, and the rest air is lighter, it goes above, and this is acting as a vent pipe. And this is a riser, or I can say a stack, which is collecting the wastewater and the soil water. So this I can say is nothing but a plumbing system. Yes or no? Or else I can say it's only plumbing, only just convenience of the water from one place to another to the respective fixture. That's it. Yes or no? But system is something because fixtures not only required the water, at the same time it demands that water to be drained out to maintain a healthy atmosphere inside the project. So now we have seen this. The plumbing system is this, what I've said you. Now let's move on. So plumbing is further divided into two parts: water supply and the drainage. Water supply is the lengthiest part. Drainage is not that lengthy, which is small when compared with this. But this is further divided into or classified into 5 parts: water and drainage. So if you see plumbing, water and drainage, 2, and further classified as cold water system, is hot water system. Here drainage, waste, soil, and surface. So we'll be seeing wastewater is water, what water will be seeing, soil water, and surface water. Surface water is nothing but the rainwater, you can say, which needs to be drained out. Okay. So we'll be seeing all these systems and we'll be seeing how to design this. So we have already seen this image. Now let's move on for the next. This is very important. Now we'll be dealing with the standard societies or the codes, I can say. Standard societies or the codes, one and the same. Now, if anyone is from HVAC or if anyone already knows about the plumbing and firefighting, I think now you people have heard some kinds of thing called as codes or standards what we do use. For example, if I give you an example, if you are in firefighting, we do use NFPA, National Fire Protection Association, and we do use an HVAC, ASHRAE standard. If India, I'm dealing, then ESHRE standard. Likewise, for plumbing, we do have some kinds of codes or the standards what we do use with respective to the region application. Yes or no? So now there are a number of codes over here specified one by one. So very first code is nothing but IPC standard, that is International Plumbing Code. Okay, and second is UPC. But this International Plumbing Code is a code or a handbook, I can say, in which we will be getting all the data to design, to install, and to select the material of the material with respect to the region. For example, there are different application codes. You can see there are a number of application codes over here, like IPC, UPC, ASP, British Standard, DEVA, and XYZ. We need to opt one. Now, how we need to opt any one? Why? Because these codes is being done on a basis of previous experience and research and development of a team. And they have said, okay, for example, if I'm dealing with International Plumbing Code, or example, I can say if I'm dealing with, I can say NBC, that is, I can say, so if I'm dealing with a project which is in India, then I'll be going with NBC standard, or the standard which my company is saying to proceed up with, because they are following the same standard. So my main concern, what I'm trying to say here is the codes and standards vary from region to region, because, for example, number one is the atmospheric condition. For example, I'll give one simple example. If I give you example of Gulf, and if you give you example of the Western countries, so what is the major difference over there? The climatic conditions. Here the climatic conditions are extremely hot. Their climatic conditions are extremely. So where the convenience or the temperature difference, what happens? The usage of the water becomes lesser or higher. Yes or no? Yes or no, online. And moreover, it comes on the people also. Like example, if as an adult person, so how much water he consumes or how much he demands, and if he's like a kid in that area, how much he demands or she demands, like that. Okay, so this is being decided by a research team, and they have put this as called as a codes or standards. So this is called as like listed below are all the codes over here. So if you're dealing with any kind of company, you'll be having this codes and standards they work for. So IPC is a code which is globally accepted. For example, if you're working in a company and they are saying, no, they don't have any kind of code. Now they said you to design a pipe size, for example, as per IPC, or they don't said anything. They said just you design with whatever the code you know, because they are not following any code right now. So you can just follow with IPC, because IPC is what International Plumbing Code you can see. So the moment you are reading international, that is internationally accepted. That means the values which is being given in that code for the designing calculation part is being globally accepted, because the values what's being given over there are on an average or a range, you can say, okay, on an average you can say for the entire world. So they can. Why? Because whenever you're dealing or designing with any kind of the design, you need to give the reference. It's not something like that I have designed and I said, okay, this is the pipe size what we needed. Yes or no? To prove that, I need to give the reference. They will be checking as per that. Then that gets approved. Then only you can install on site. Yes or no? Based on approved shop drawings only, we do the. This is IPC, that is International Plumbing Code. You can write down in bracket or you can note it down. This IPC is globally accepted. Anywhere part of the world, you can use this codes. Okay. What is code? I'll give you the definition of that also. Next is UPC. UPC stands for Uniform Plumbing Code. Now this is commonly used in the terms of Gulf area and US. Okay, why? Because this is suitable for that region, and this code is especially having the values for these regions only. So if anyone is dealing with the projects near in this particular region like US and this Gulf countries, they might use this, and IPC can also be used. It's not a problem then when I'm saying you only UPC. No, it's not like that. IPC can also be, but if your company is saying no, we do follow UPC, then you need to go with UPC. Okay, so UPC again a standardized thing for the Gulf and USA. Next is ASPE, American Society for Plumbing Engineers, specialized in again USA. Okay, next is British standards. Now if you're dealing with a project which is in UK, so we will be following this code, that is British standards. London, UK. Okay. DEWA, that is Dubai Electricity and Water Authority. You can see Dubai, it seems. That means what? For the Emirat, you will be using this complete. Okay. Because again, the values, what's been given over there, or the material or the installation methods as per that particular area or that region. Next is Royal Commission, that is for used in the KSA, that is Kingdom of Saudi Arabia. So this is standardized handbook or application book for this area or the region. Okay, complete. Apart from this, IPA, just now he said, again, this is also from India. It has been used, that is Indian Plumbing Association over here. Then ASHRAE, again, ASHRAE is something, American Society for Heating, Refrigerating and Air Conditioning Engineers. Again, this is also one code which we use for, again, something that's for the heater selection and all this. Again, don't get confused. It's from HVAC. No, some part we might take for this, because the values also been provided. There is one more code. Again, we can use as per the company. If they are saying follow ASHRAE, because my company used to follow ASHRAE standards for the pipe designing. It's not something like that you need to go fix with this. Now they will be saying you what code. Like example, you people have said me number of things over, like you are following UPC or IP or NBC or whatever the standard, based on their application or based on the region will be doing this. Okay, so this is again, and one more Qatar Kharama. This is again used in the Qatar. So these are some popular known codes over here. Apart from this, there are like NBC, he said. There is one more thing, NPC also, that is National Plumbing Code. That is again for India. Okay, so there are a number of things, UPC and IPC, NPC, NBC, and ASHRAE application handbook. There are a number of things over here, different codes over here. But why is this codes required? So I'll give you more clear idea. The plumbing code is a code that provides recommended values. Recommended values for what? For the calculation purpose, you can say, for designing. Okay, that means technical thing I'm saying, for the load calculation. So we'll be getting some values for the designing purpose. Like example, by opting that values, one can do the design, and sizing. I can do sizing. Yes, please. Why do we need these kinds of codes over here? So now, as I said, plumbing code will be giving you the recommended values, okay, based on their research or their previous experiences. Okay, this is perfectly fine for this application, for this number of people, for this region, for this material. That's it. Okay, recommended values for the designing. Then sizing. Sizing refers to, it might be any kind of size, pipe size, or number of things which we are about to size. So sizing and installation guidelines. So for example, it gives you the guidelines for the installation, how are the things to be installed, and the material for the project. For example, if you're dealing with any kind of project which is nearby to the seashore, then if I'm dealing with GI, then it won't suggest you. It will say, no, don't go with GI, because the humidity ratio is very high over there, because we know that nearby the seashore, humidity is very high. What is humidity online? Can I say? What can we say for humidity? Moisture present in the air. Can I say moisture
Percentage.
Moisture content is very high in that air.
Moisture content in the air.
So what happens when moisture and air mixes to the material?
And rust and erosion.
Yes, it's
Corrosion.
right? So this material, just an example I'm giving you so that you can visualize and say, yes, okay, codes will be helping this. So what code will be saying, if you're having a project nearby to the seashore, it says don't go with the metallic property of the material, go with non-metallic plastic category, because there would be no problem for the installation in future also. That means it will not get corroded and all this. Or else if it's like if you want to go with metal only, then you can go with copper, but that would be very expensive option, isn't it? So likewise, we'll be getting some instructions for the designing, for the guidelines for the installation, and guidelines for the sizing, how you need to size, for example, the pipe size, or how you need to select the pipe diameter, or how you need to size the grease interceptor. Just an example online. Or sump pit, if you're doing, how you need to do the sump pit, or how you need to have a pump room, or how you need to select this XYZ, the information all about the respective things. So these are the things which is giving all the guidelines or the tracks which you can follow, so that you can say you have done the project in a standardized manner. Yes or no? I can say that. This was about the plumbing code. So these are the things what will be getting the help from the plumbing code, and these are all list of the plumbing codes. Now, why do we need this codes? Now, this is very, very essential, important. We have already learned something over here. Now, let's see in the technical manner and exactly how this can help us. Okay, so by taking an example of one code. So why do we need the plumbing codes? Plumbing design based on the probability, except special cases like evolution tab and residential school. Therefore, to design plumbing, standards and codes are required. So always remember, right now we are dealing with a plumbing industry and we are dealing on focusing on specializing on the residential area. We'll be dealing on complete project that is resident only. So what is happening over here, whenever you deal with the plumbing designing, mostly in the I can focus on the residential, we do the pipe sizing mostly on what? The probability basis. Now, what do you mean by probability? Can I say chances? For example, I'll give you one simple example online. This is a bathroom. Yes or no? Yes or no?
Yes, sir.
And there are two fixtures over here. One is WC and one is laboratory. So what do you people think, that this fixture and this fixture both will be getting used at the same time? That means at the same time the flush can be done, at the same time the water can be used for washing his hands.
Probability 1/2.
1/2, right? So that means chances are that only any one might be using at the same time, right? Yes or no? So whenever we are dealing with this, mostly remember any kind of the project residential, mostly we deal with the probability, that is the chances. This was the example, just two fixtures, might be 3, 4 fixtures. So only amount 5, I might only use 2, not more than that. So that is the chances, and the values, what we do see in the application handbooks, that is based on the probability. Yes or no? Yes or no online?
Yes, sir.
Right. So this is what plumbing always designed based on the probability, except special cases, but not all the cases probability, because we do have some special cases also, like example, WC at the same time, laboratory at the same time, and the continuous thing. So that is some special cases. What are that special cases? Case number 1 is ablution tap. What is ablution tap? Ablution area where we perform or where we offer wuzu. Like example, wudu, like before offering prayer, we go and we wash hands and face and all this. So we know that example, prayer at a specific time. So before that time, all the people gather up over there. Yes or no? So, and there is maximum usage of the water and it will be maximally occupied, the number of taps over there. So this is a peak demand. I can't go with the probability basis. For example, no, only 10 taps, okay, it might be 3 or 4 working. No, I can't go with that. I need to go and design on the peak demand, considering in mind that there's all that 10 taps in that particular area will be used at the same time. That's what, yes or no? The size of the pipe or the main header would be bigger. If you go with probability, that would be lesser. Yes or no? One special case. Second special case is what? The residential school. Residential school is a school where candidates come over there, attend school and again go back, and they stay in the same premises. So what happens? For example, they have school at 7 a.m. in the morning. So everyone wakes up at 5. So the number of wet areas over there, like example, all the toilets, all the bathrooms will be used at the same time. For example, 10 bathrooms side by side. There is chances that all 10 bathrooms will be used on a continuous base, that to all the 10 WCs as in use. And again, same thing like showers, all 10 showers will be working at the same time. Yes or no? So if I deal up with this by using the probability values, my system will fail, because it is not being designed, or it's not should to be designed on a probability basis. That should be designed on a peak basis. That means considering, yes, all the fixtures which is being installed over there as per this application special thing, I need to consider that all fixtures to be considered that they are working or they will be working, and they will be working for sure. Either with the probability or the special cases, you need this plumbing codes, because from this plumbing codes, one will be getting the codes or the values to design on the probability basis or design on the peak basis. So we'll be having this code. So in short, we'll be getting some recommended values based on the probability or based on the peak demand. Example, peak demand, what should be the value? Example, probability demand, what should be the value? We'll be taking help of this. Okay. So today is end of the session. some codes and what are the codes and why it can be used and where it can be used. So we got this information. Now we have already seen what is the plumbing code. Quickly, I'll just do the revision and let's move on for the continuation. So plumbing code is nothing but a code that provides the recommended values for the design, sizing, installation guidelines, and the material of the project to be selected. In short, well, why do we need this? Is very, very, very important. We have seen this whenever we are dealing with any kind of the project. Like example, there are different applications, I'll say here. One is residential, what we are gonna deal. One is industrial, one is commercial. Okay, or I can say in commercial everything comes, but if you talk about in plumbing, I'll be saying only two things, because as per the codes there is only two things, like one is public, one is private. Private refers to all residential, public refers to all the things like commercial, industrial, everything includes into public. If I say you public, okay, keep in mind that is industrial or commercial, or it might be apart from residential. Private is only residential. It might be a high-rise building, it might be villa project, or it might be independent house, anything. I hope you guys are following, please.
Yes,
Now,
sir.
Yes.
yeah, plumbing design is mostly based on the probability basis. As I said, probability is nothing but the chances. And I've given you an example, simple, like with the diagram, like there is a kid in the previous page, while he's trying to hold or collect some water in one container from the laboratory, and his behind is WC. So there are two fixtures in that particular bathroom, so that both cannot be used. So we will be designing a pipe keeping in mind that only one fixture will be getting used at the time. So that is probability. This was among only two. So we have like 10 or 15 fixtures also. Now I can say that not all that 10 fixtures or 15 fixtures will be working at the same time. Now this is the case about maximum kind of the things, like example, the maximum projects. Even if you go with residential, commercial also, you do have this kind of probability applicable maximum applications. But there are some applications where we demand like a peak demand. That means if I'm having 10 to 15 kinds of, if I'm having this 10 to 15 fixtures, and I'm giving you example of residential school. Okay, so what happens over there in residential school online? We know that the person or the students stay in the same premises and they go back to their, where they stay. Again, they come back. So as I gave an example, like yesterday or in the previous session. So like example, school at 7, everyone wakes up at 4:30 or 5. Number of students, like 300 students in that premises staying. So the number of showers, like 10 or WC 10 or 30 or 40, whatever it might be. There has been 10% chances, that's the maximum chances, that all the WCs we're gonna use at the same time, laboratories at the same time, the showers at the same time. So I cannot design the system in this scenario with applicable with the probability, because it's not the thing over here that I can go with the probability, because it's a peak demand that I know that in future at the particular time, specific time, early morning, because everyone have the school at the same time, everyone needs to reach the school within the time, right? So in that particular time, keeping in mind, everyone wakes up, put the alarm at the time, and everyone tries to go to school within the time. So there has been 10% chances that all the fixtures will be getting used. So we will be getting this respective values for the designing or the selection of the pipe, or what kind of diameter, or to maintain the velocity. We'll be getting this respective things with respect to the codes over here. So you need not only to check what kind of application you're dealing with, you need to check whenever you're dealing with the pipe size, you need to check, okay, this can be a peak demand or this can be a probable demand. That's clear, everyone? Yes or no? So,
Yes,
yeah,
Yes.
keep in this mind and let's move on then. Except special cases like ablution area, yesterday discussed, and residential school. I can give some more examples, like I can say in function halls, like maximum people, like in laboratory tray, that will be used, maximum taps will be used at the same time. Or else I can say if you go to a multiplex for a movie and all this, in the interval, the urinals or the laboratories has been occupied mostly, all at the same time. Yes or no? Just an example only. So therefore, to design plumbing, standards and codes are required. Now this paragraph is very important. Let's move on and check what exactly, as I said only 2-3 things over here, but I get more information apart from that information what is being provided in this notes. Like I said okay, let me come back by reading this, then I'll elaborate this. Where building contains plumbing fixture, everyone knows this. Whatever the building or whatever the application we are dealing with, whether it's residential or commercial or public or private, in short, in that we do have plumbing fixtures for sure. Yes or no? Like what is plumbing fixture? Just said like WC is one plumbing fixture, laboratory is one plumbing fixture, shower, These are all what the plumbing fixtures. What is plumbing fixture? Technical definition will be coming ahead. Okay. So now a building contains plumbing fixture. Those fixtures requiring water must be provided with an adequate supply of water for proper operation. So now, for example, just try to visualize, okay, then you can get the concept. Let's take an example of shower, everyone. So now shower is in plumbing fixture, and I'll be getting some information from all the fixtures for any of the code. You take any of the code. Now, just for your information, I'll be dealing with IPC, that is International Plumbing Code. So mostly whatever I'll be dealing is with IPC, most of the things. Okay. So this thing, we are assuming an example for the shower. So in shower, we require a sufficient or an adequate amount of water. That means a sufficient amount of water which can come out of the shower. Okay, that is in terms of GPM or LPS, that is liters per second or gallons per minute, whatever it might be. I denote that as Q. That is Q equals to, or Q is assigned for here is the flow. Okay, online. Q always remember in plumbing is nothing but the flow or the discharge. Okay. And there is not only one thing, there is two things over here. So that one is velocity. Okay, what is velocity online? Anyone?
Area and velocity.
No, what is velocity? Definition for velocity?
Yeah, distance per unit of time.
Very good. Very good. And apart from this, in simple words, anyone? Can I say speed? In simple answer.
The speed of flowing, the speed of fluid.
Yes. In simple words, just to make it easy, what is it is accurate. Okay. So now there are two things always remember that every fixture demands. Like example, if you consider one is shower and one I'll say laboratory. So everyone has come across this. So the moment I have on the shower, I'll get a different amount or the flow of the coming out from the shower, and I have on the tap or the faucet from the laboratory. I mean the wash basin, I'll get a different amount of water. So what do you people think? Which flow is higher, in the shower or laboratory? Yes. Which flow or which discharge is higher online? In the flow, I mean the discharge in shower is higher or the discharge in the laboratory is higher? Yes, anyone?
Discharge in shower is higher because it should take the pressure from the roof tank, and laboratory has a separate tank.
I'm talking about the discharge, not the pressure right now. Discharge I'm taking because as
discharge at the laboratory.
Yes, not laboratory. No. Why? Because laboratory is only for washing your hands or face. That's it, isn't it?
Oh.
But when we are having a shower, it's for the complete body. So based on that, every fixture demands a certain amount of water with a sufficient, not amount of water. Every fixture demands water. Okay. But the sufficient amount of water to be served so that the fixture will be working in a proper manner. For example, I'll say shower demands 3 gallons of water per minute. That means if I provide or if I give 3 gallons of water for shower, then this will be working in a proper manner. If I give 2.5 or 2, this is not going to work. And this both pressure and what? Q, both is directly connected. Yes or no? So with that pressure, I'll be having some velocity or the speed also. That is like example, I can say 4 or 5 psi. If I get less pressure or if I get low GPM or the discharge coming out from the shower, that will be not accepted. Why? Because it will cause inconvenience for the person in the future. It will take more time for having shower, isn't it? So it's been delaying for the times and all this. So now what I'm trying to say here is every fixture, every fixture, what are the fixtures we'll be seeing future. So all the fixtures demands different amount of flow rate and different amount of the pressure in terms of PSI. Units of pressure is PSI. And here Q, we are dealing with gallons. I mean, I'm dealing with IPC. So I will be saying you that how many gallons of water is being required for this fixture and how much pressure is required for this fixture. Okay. So we'll be seeing this. If the pressure or if the water is not supplied what exactly it is being asking for, then this will cause discomfort. And in plumbing, always remember there are two things whenever you size up a pipe. Oversizing is also not accepted. Undersizing is also not accepted. What happens in oversizing? First of all, you're decreasing the velocity because you're doing expansion of the pipe. For example, 1 inch of the pipe is more than enough. If I'm going with 1/4, what am I doing? Automatically, I'm giving a wider range of the pipe. So what happens? The velocity drops into that, isn't it? Yes or no? If I'm having 1 inch, I'm going with 3/4, then what happens? I'm doing compressing into this because
velocity will increase.
Yes, because it is compressing, because the dia is lesser. and the Q is higher, isn't it?
Yes.
So this compression who happens over here,
Yes.
that is also not accepted because again it is related to the pressure now. Because example, if only 5 psi, but I'm getting 10 psi because of compression, what happens? The velocity will increase, isn't it? Yes or no? That
Yes.
will
Yes.
damage the picture. So in plumbing, always remember neither undersizing or oversizing both is not accepted. If it was firefighting, oversizing is accepted because that was for the safety thing. So that is accepted. That is different scenario. But in plumbing, no, what is required, we're gonna go with this because we need to maintain all the things. What? I need to maintain the Q. I mean to maintain the velocity also, not decrease or not increase, both the things. Okay, so we'll be seeing this. So from the codes I'll be getting is first of all the fixtures, demand of the water and the pressure. Now I'll give you one simple example. For example, if someone is having a bath, I can say, or someone is using a laboratory, okay, to clean their hands. The pressure in the laboratory in India and someone is using laboratory in some Western countries will be the same pressure. It's not something if that's a different country, I'll be getting the same pressure. Yes or no? Because he's also the human and he is also human.
Yes.
Right. So that's what. So this codes like IPC are specialized, internationally accepted. So that's what I'll be dealing up with this. And what we are going to train you here is for you'll be getting the complete concept of the designing, and you can apply as per your local codes over here. Only just the value changes, but the steps and the design procedure remains the same. The first thing, remember online, very first point in this second paragraph I got is, or we'll be gonna checking that where are the listed things over here in IPC, there where I can find out that how much Q and how much pressure, I mean the PSI is being required for each and every fixture. We'll be seeing that. Okay. Now, second number, that is point number 2 in this paragraph. The number of required plumbing fixtures is specified by this code, and this based upon the anticipated maximum number of occupants for the building and the type of the building occupancy. Now, in this, what is saying, before this, I'll say you something. For example, everyone, I hope you people are into this stream and you're all aware of this. Now, for example, I can say when there was an architect, okay, and he does all the things over here that he has drawn a layout, architecture layout, and all this. So he will be sending that architecture layout for the designing purpose. Yes or no? With respect to all the services, either MEP or the complete building services. Yes or no? In that, they'll be doing their design load calculation. Now, designer, or sorry, the main consultant or an architect is a person who decides the plumbing fixture. We are not the one who decides the plumbing fixture. For example, in the toilet, I'm saying here is one WC, beside that one shower, beside that one laboratory. Example, I'm saying he is the one who is deciding the number of fixtures. Yes or no? For example, if you have seen any of the layout, okay, we will be only doing the single line diagram. Previously, if you see in that CAD layout or in that architecture layout, in the same format, the fixtures will be shown. We are not the one what we are placing it over there. Yes or no online?
Yes, sir.
Yes, sir.
Right. So first thing, but in case architect has not done anything, he has just given you a layout, like just saying the spaces, like this is this, this is this, this is this, and he has nothing shown in that, and he's saying this is a toilet, this is master bedroom, and he's saying XYZ, and he has not given you the fixtures over there, and he said you that is a small project, you go with your own experience. So need not worry, while having this handbook or application book with us, one can find out the minimum number of required fixtures. Okay, so we can find out that. So there is 2 points over there. And one more we'll see. Third point is what if you see over here, this code provides the prescriptive criteria for sizing pipes connected to those fixtures. Now, third point is trying to say is, if you know the fixtures and if you know this GPM and all this, one can find out the pipe size by having this information. But before this, let me first of all show you these 2 things or 3 things how we need to first of all find out if there is nothing is given. So as I said, I'll be dealing with IPC. So these are the reference books over here, application handbooks, and I'm dealing with International Plumbing Code. I'm dealing with 2018, the latest what I got so far. Table number 403.1. But before this, everyone, this code is nothing but International Plumbing Code. Version is 2018. You can see this, and this is chapter number 4. And this chapter number 4, and I'm here to find out the minimum number of required plumbing fixtures. Like as I said just now, the architect has said, you go and find out what are the minimum number of fixtures required. Now, as we are all humans, and this is for this human comfort, either it is like residential, commercial, or industrial. So there are some basic requirements. So that's what these are some basic kind of plumbing fixtures which is should be there in all the applications. It is residential, commercial, or industrial, or public or private, in short. So you can see first is WC, that is water closet. Second is laboratories. Third is bathtubs and showers. Fourth is drinking fountain, and fifth is other. In others, we'll be having is mostly servicing. That is used for what? In the service. It might be any kind of servicing. It might be a kitchen sink, or it might be for refers to, I can say, a janitor sink. Okay. Now it changes with respect to the application. Now, for example, you can see this is number one. I mean the numbers, and this is the classification, and this is the description. In assembly, we are having three descriptions over here, and the same thing over here, because this consists of one. And if you see here is again still one continuation. In assembly, we are having this more things over there, this application. For example, assembly area in the gaming areas, and that assembly is in that gaming area. So one can take help of this. But fixtures remain same, only the quantity changes over here. Here we can make sense. Yes, WC is a common requirement and a laboratory, and I can say bathtub or shower. Now don't get confused, bathtub or shower. It might applicable in some applications, it might not applicable in some applications. Yes or no? Drinking fountain, it will be applicable in some cases, maximum cases, and servicing might be applicable in some not. Okay, so now for example, let's do one simple example by having like, let's do with this. For example, if I'm dealing with institutional, okay, and this is for educational facilities, and this is institutional, this is factory, this is for the business, and this also you're having what kind of business and all this, you can just check over here, building, banks, light industries, and similar users. So now let's take any one example. So let me just go with this residential, because we'll be dealing with this. I'll do two examples. First of all, this would be somewhat difficult. We'll be moving with this. For example, institution. In this, I'm going with, let's go with this. This is prison. Okay, let's go with this. For example, we got a project, and that was a prison. It needs to be construct somewhere, and he has set a small prison over there, and he said that you just go with the plumbing fixtures as per your experience. Okay, but not my experience. I need to give a reference also, and then how and where I have done. So I'll be giving is like I have taken the reference of IPC 2018 application handbook, and I need to provide the table number. You people can note down for your reference 604.3, sorry, 403.1, and the table number is this, and the number of this name of this table is minimum number of required plumbing fixture. Okay. This is 4th chapter 2018 IPC International Plumbing Code. So now, for example, prison, this is one per cell. What is saying one per cell? If you go this, what is it talking about? He's talking about, this is WC. That means in one cell, for example, I'm having 50 cells. Then how many WCs online? Can anyone?
50.
Very good. So 50. Next is what? If you see over here, beside that, I'm having, this is for the laboratory. So he's saying again one per cell. So in one cell, I'm having is one WC and one laboratory. That means 50 and 50. I'm just giving you an example, like 50 cells we have just assumed. So 50 WCs we required in that project, and 50 I required is laboratories. 1 per 15. What is this 1 per 15? Now this might be for shower or the bathtub. So there will be no bathtubs over there. It's a prison. So it would be showers. So that means if there is a prisoners at a time at 15, one shower is more than enough. Now, as I said, there is a 50 capacity over there. Might be that all 50 can come. So as per that, how many showers we required? Anyone can say that?
4.
4. Exactly, I can say 3, but not 3 exact, because more than 3. So I'll be going on a higher side. If you want, you can do some calculation minus, you'll be getting that 3.5. I can't say 3.5 showers or 3.25 showers. I'll be directly saying as 4 showers to be on safer side, because one shower has been required for 15 prisoners, isn't it? And we are having a capacity of 50. So if I divide that by 15, I'll be getting 3 point something, isn't it? I'll be going by 4. Hope you guys are following. Yes, please online, everyone. Next is what? The drinking fountain and other we'll be saying. So now drinking fountain, yes, they required the water also for the consumption for them. So 1 per 100, that means 1 is enough, more than, because I'm having a maximum capacity of only 50 only. Okay, so but he's saying 1 per 100. That means in 100 people, 1 drinking fountain is more than enough. So I'm having double the probability. That's no problem. I'll be having only 1. I don't have half of that. Can we have half of, this drinking fountain? No, no, that is 1 only. Yes or no? And 1 servicing. Now it might be servicing just to clean their utensils by their own and all this. So this can be 1 example. Okay. Now let's come back and one more, like case number 2. Let me tell you, let me take some other case for you people so that, okay. let's take this in assembly. Like we are dealing with some religious place. It might be any religious place. Same thing. So WC, laboratories, and bathtub and shower and drinking fountain and other. These are common things always. But the probability, as per the probability or as per the application, this values changes, and this values as per the probability. Always remember online, not the peak demand. Peak demand we need to find out. Okay, so how? I'll say you, for example, 1 per 150. For example, if I'm dealing with any religious place here, now this is classified into two things, male and female. Can you see? So this is WC. In this two classification, for example, in the worship place, I'm having WCs like male section and female section. So if there is a probability of like 300 people gathering at the same time, like 150 male and 150 female. So how many WCs online can anyone say? So what 150 WCs means? One WC is okay for 150 men, but here 1 per 70
Four,
for women.
6 total.
Here how much? No,
Six.
6, 3,
4.
3.
150, 300 people are there, no?
No, first of all, I'll say you,
100.
this is
Here
what,
we need 4. For females, we need 4. And for males, we need 2.
no, see, for example, I'll say you, let's do it one by one, don't get confused. So this is 1 per 150. So 150 male, so I need 1 WC as per the probability, more than sufficient. But 150 female, so 75 times 2 is how much?
2.
2.
So how many WCs? 2.
2,
Yes.
2 WCs.
So total is how much? 2 in women area, 1
Three.
in men area.
3.
3.
3.
Right. Now,
3.
yes. Now one in laboratories, 1 per 200. Now here, you if it is like if I talk about some projects which is like in UAE or sorry in Gulf countries, I can say there is something entirely different. Like the entrance for the women's is different, for the men's is different, and there is men's majlis, women's majlis, and all this. And if you go in Gulf region, there is entirely different, like men's, women's, and bathrooms area also. So in that case, this is applicable. But here it's not given for the laboratories. It's common, but no. We'll be dealing 1 per 200. It's given for common in both male and female. It's not divided. That means it is applicable for men. It is applicable for women also. So I can go with one laboratory because if 200 persons, one laboratory is more than enough. And 200 female also, one laboratory is more than enough. So here is 150 and here is 150, what we have assumed. So that means 2 laboratories I need, in one in women, female area and one in male area. Yes or no? Or else it's combined, then this is 300. Still I need 2 only. Yes or no? Because see, it is 1 for 200, but the total number of person, it's a common hall. For example, I'm saying laboratory, then the total number of persons are 300. Yes or no? Because 150 and 150, what we have assumed. So, but here, as per this code, I got information that if the laboratories, I need 1 for 200%, but here is 300. Then, even though I need 2, yes or no? Following on.
Yes. Yeah.
So I can 1 in male and 1 in female. I can do that.
Yes.
Next is what? There is no bathtubs and showers required because it's not residential or it's not commercial. Why is it commercial? Because hotels and all this comes into this, because in that we do have the showers, bathtubs and all this. Or if it's like some other sports section and all this, like we do have sauna centers and gyms and all this, and swimming pool units if we have. So they would be having a shower, then this would be considering over that. So not only in residential, we do have some commercial spaces also where we might have bathtub or we might have a shower. Okay. So this is not applicable over here because it is a religious services over there. Okay. And 1 per 1,000. That means one drinking fountain is more than sufficient enough to serve 1,000 people, and 1 is more than enough as per their experience, as per this code. So total number is 3, more than huge. Only 30% is I'm having. This is more than required. Yes or no? So one service thing again, if it's for example, they have some gathering or something, they want to have something, they can clean the utensils over there or something like that. So this is one servicing is required for this. I hope you guys got the concept, what I'm trying to say. But don't get confused why I said you, in case, if the architect has not given you the pictures, you can extract from over here and you can say as per this code, as per this year, as per this table number, from this I've extracted the pictures as per this application, this number of WCs, this number of laboratories, this number of bathtub or shower or drinking fountain or the sink or anything, whatever, or the others in the sense. Okay, following online.
Yeah.
So this was which point number can we say? Anyone? So this was we have found out the minimum number of plumbing fixtures required. We can find out this. Okay. Now there is one more thing. We have missed the first point, that is adequate supply of water for the proper operation. So we have discussed that all the plumbing fixtures will require some sufficient amount of water to work in a proper manner. That is flow, Q, and that is V, velocity. Or velocity is something I'm talking about right now, the pressure, PSI. So I need both the things over here. So now that is again predefined. Now you don't get confused. It is predefined. So what are we doing? No, it is predefined just for the inspection. If they see this and if they check, okay, it's as per this code. If I get that much of GPM and that much of velocity, it's approved. Then you can get the release of the money. And what is this? Who will be doing this online? Tab work or who? Tab work people, right? Who will be doing this testing, adjusting, balancing? Who will be giving this approval online? Tarun?
In India, PH is the authority who give the authority for pipeline or water supply.
No. I'm talking about who does this. Tab work people, right?
Plumbers.
Plumbers. Tab work, that is called as tab work. That is testing, adjusting, and balancing. That's a third party. They come and see that what the designer has done, whether they have followed codes, okay, that's done. But they need to again recheck that whether it's working as per the code or not. Okay. Then if we are getting the same kind of, the output, then it's been approved. Anyhow, so first of all, this was the second point. Now let me show you one more point, and I'm having more 2-3 things to show you. And most important, let me tell you one important thing over here, that we are here to find out the main pipe sizes, not the branch pipe sizes. Branch pipe sizes, nothing but not the branches main, which is connected to the main pipes. I mean the pipes which is connected directly to the fixture. Okay. So that sizes is also predefined. Predefined, that means it is directly given from the codes. One can find out. Same thing. I'm using ITC and table number 5037. Yes, if you see over here online, is this table visible? Table number 604.3. Yes or no? This is water distribution system design criteria, required capacities of fixture, supply, pipe, outlets. So now these are all the listed fixtures over here. Okay, and here is the flow. That means this fixture demands this much of the GPM or the Q and this much of the pressure to work in a proper manner. If it's not, then it's not working in a proper manner. That means it's not giving the full efficiency of why it is designed for. For example, like I just said, shower demands 2.5 gallons of water over a minute. That means in 1 hour, it needs to get 2.5 gallons. And how much is 1 gallon in terms of US and UK? Can anyone say me? How much is 1 gallon of US?
3.75 liter.
How much?
3.75.
3.7.
3.785. Exactly. Yes, 3.75. Exactly. That is liters. Okay. So now you can imagine just
Liters.
2.75 into 2.5, that would be something nearby to 8, 9, 10 liters, I guess. So we demand, or this shower demands 10 liters or nearby to some liters XYZ or 2.5 gallons over a minute. If it is getting, then this would be served the process for the shower, I mean for the bath, and this requires 8 psi. So this is constant or global, worldwide. These are all the things over here. It's not something Western countries or Eastern countries or Asiatic countries, this will be decreasing or increasing. No, it's standard. Okay. So just one more example, like drinking fountain. This is 0.75 gallons of water is being required because it's the consumption of the water directly for humans, and this requires again 8 psi. That is PSI, that stands for
Per square inch.
Pressure per inch.
pounds per square inch. Now, sink, residential, sink service, urinal valve, number of things over here. So we'll be saying, okay. So this is one thing what I said you. So we got some information that this fixtures which demands not only the water, it demands a velocity or the pressure to work in a proper manner. And these are the listed Q and P, or the velocity I can say, for all respective fixtures. Now, second thing, just now I said you, one more thing, that we are here to design the main pipe size. That is the main pipe sizes, not the pipe sizes which is connecting to the fixture. For example, what kind of pipe would be connected to the faucet of the laboratory? We'll not be designing. Like example, if you have gone through the plumbing, we might have seen this mostly half inches is being connected to the maximum fixtures. Yes or no? Same thing. So here, as per the table number 604.5, minimum sizes of fixture water supply pipes. So the pipe sizes is also given, which is connected to the fixtures. But this pipe which is connecting to the pipes, main branch or the main, we need to find out. Yes or no?
Yes.
If you are installing a bathtub, the main pipe size which is will be connecting to the bathtub directly, which is serving to the bathtub, I can say, that should be of half inch. If the bathtub is of this inch, 60 by 32 and smaller, half inch. If it is larger than, still half inch. Okay. width 3 by 8. And these are all the things, like if we are dealing with domestic dishwasher, half inch is to be connected. This is in terms of inches, okay, not mm. So these are all the things over here. For example, you're seeing n number of things over here, and you can see mostly is half inch, half inch, half inch, half inch. That's why what they does is plumbers, for example, they don't do the calculation. Yes or no? They does all the plumbing. If there is no design, then the plumber, if we give it to them, what happens? They just do it on a practical basis of their previous experiences. Yes or no? And they'll be having some problem with that. We'll be
Yes.
dealing with that also. What problem we do face, and what is the problems if they design, if they install without any calculation. What are the problems we do feel in the future? We'll be seeing this. Okay. So now you can see there is some velocities also given. For half inches nominal pipe size, is saying the velocity should not exceed 4 feet, okay, and 5 to 8 feet. Don't worry, we'll be coming to this back later on. Okay, so these are some things over here. So in the codes, again, I'll be getting help of some more things, like I can find out the minimum number of pumping fixtures required with different applications by using the table, and I can find out that what pipe should be directly connected to that fixture. Okay, not the plain pipe, because we are sizing that, but this is ready-made given from the code. And one more thing, we got also some information, or we can visualize that, okay, this fixture demands how much gallons of water in a minute with what velocity, yes or no, or the pressure. Following online, so one can use this.
Okay.
What happens over here is,
Yes, sir.
this code provides prescriptive sizing criteria for sizing piping system connecting to the fixtures. So the code, use of code approved materials. Now we can find out the approved materials. I given you a simple example here, a previous session, that like example, nearby the seashore, if there's a project, I said you, they recommend me to go for the non-metallic category of the material to install, so that there is no corrosion problem or something. Or else you can go with metal, then you can go with copper or something, or you can go with stainless steel also. But again, stainless steel also do corrode. Yes or no? Stainless steel do not corrode only?
Yes.
Corrode or no?
No, stainless steel, no corrosion in stainless steel.
If it's contact with acid in any kind of acid, so it also get corrode sometimes.
There is one term called as corrosion resistant. It is a corrosion resistant. That means it has some resistivity till some extent, till some time. That's it. But copper is a natural resistant for corrosion. Copper might also corrode, or no? Anyone? No one idea? Copper do corrode?
So, copper also corrode, but it to make a thick layer and it not the wetness or the humidity is not able to corrode the copper. It may long lasting. It take more time.
It does not have that impact, because copper is a natural corrosion resistant. Okay. Through the use of this code, approved materials and the installation requirements specified in this code. Not only the approved materials, it will guide you how to install the things, so that the plumbing system will be performing their intended function over the life of the building. So if you have all these things in the mind, and if you go as per the codes, like you are dealing with the designing with respect to the code, what is being given or what you're following, like you have opted the values from over there, you have maintained the velocity, you have maintained the pressure, and you have opted the required sufficient amount of the water as per the code, and you have done the installation as per the codes, what they are saying, and you have selected the material as per the codes, what they are saying with respect to the region and the project. So you can expect the life of the building or the project in a good manner, or else you can't. For example, any project or any material what we have installed, they were saying that the life of this project or life of this complete piping or this material might be, for example, 20 years or 10 years. We have not followed any standard. We have just installed on a practical basis. I can't give any warranty. Yes or no? It might go with 10 years, it might go with 15, or it might go for 5 also, 3 also. Yes or no? So that's the importance over here, to have the codes in our industry to follow for, okay, to maintain a standardized things over here. So now plumbing systems, we'll be dealing with domestic cold water, domestic hot water, garden sprinkler system, and this is the drainage. So drainage, waste and soil, we'll be seeing vent sizing, single stack, double stack, and storm drainage system, or the rainwater system we'll be seeing up with this. Okay. without further. So chapter 1 is nothing but again the introduction. And in this chapter 1, we'll be seeing the plumbing fixtures and the applications. What is a plumbing fixture and what are the applications which will be used in the plumbing industry? So very first thing, again, introduction, the same kind of definition. What exactly is a plumbing? So we have learned that plumbing is any system which can convey fluids for a wide range of applications. Now, fluid refers to a liquid or it's a state of matter, you can say, like liquid. Okay, and fluid is something which can flow in a given direction and by having some external pressure on it. Okay, so now fluid refers to liquids and gases, I can say, apart from solid. Solid is not a fluid. Yes or no? Fluid refers to fluid, which can flow in some XYZ direction when there is a pressure exerted on it, on me acting on it or behind it. Okay, so that one place to another. So gases can also be transformed. For example, if I say you water is the best fluid, I can say yes or no, or else I can say gas, nitrogen. Nitrogen is a fluid. It's a kind of fluid. Yes or no? You can sense it, isn't it? Online, yes or no? So these are the fluids over here. So I think you got what exactly fluid means. Fluid is nothing but liquid or gases, you can say, and which can flow from one way to another when we have some pressure acting on it or behind it. Okay. So this can be used in many applications. In short, here the fluid refers to the water because we are dealing into the building services. And building, we have what mostly the fluid as the water as a medium. Yes or no? So we'll be saying the same over here. We'll be ignoring this. We'll be saying at the time of dealing with the project. Now let's deal or see what exactly the fluid we are dealing is what. So some basic knowledge about the fluid, what we are about to deal. As I said, the fluid, what we are about to see over here, the medium is the water over here, fluid. So let's see some simple chemistry of the water. So water is a chemical compound. It is a liquid which boils at 100 degrees centigrade and freezes at 0 degrees centigrade and consists of water molecules. It's simple enough online. 100 degrees, you know, evaporation starts, and 0, what happens? Freezing starts. Yes or no? Yes or no?
Yes,
Yes, sir.
So each molecule, so as I said just now, and it consists of water molecules also. Water molecules contains of 2 hydrogen atoms to join to 1 atom. And from this only, we can say as H2O, that is 2H, that is 2 hydrogen and 1 oxygen. That's why a chemical compound name or a chemical formula, what do we say as a chemical engineer? I think it's very common. We know H2O is also known as for water. Yes or no? Same thing. We call water as H2O also. That is nothing but 2 hydrogen and 1 oxygen atom in that. Following online? It's an excellent solvent. Why? Because there are a number of minerals dissolved into it, and it can be dissolved into any kind of the matter over there. Yes or no? So it's an excellent solvent, I can say. And a result, normal drinking water contains dissolved substances such as iron, manganese, calcium, magnesium, sulfate, and fluoride. So these are all kind of what? Solvents over there. And these acts a very real good impact on human health. We do need it, we being a human. So this again is a very essential for our body. And you know that our body needs 70% of the water, 30% is food. Okay. And if you have a good pH range of the water, we can survive only on water also. What is pH? We'll be seeing that is potential of hydrogen. Okay. So this is an excellent solvent, and this is what we are having is these all solvents over there, and we'll be seeing what is it. And it is having some gases also. It also contains some dissolved gases that includes oxygen, nitrogen, and carbon dioxide. Many of the above minerals are essential for the health and proper growth for our bodies. So as I just now said, these are all important, very important or essential, you can say, for the proper growth, especially for the growing kids and all this. And to function, I can say for us to function our body in a proper manner, we require this all solvents like this gases and all this minerals, which has been present in the water. So now presence of these minerals usually imparts a more pleasant taste to this water. When you have the sufficient enough amount of this minerals and this gases over there, it has a more pleasant taste in the water. When you sip it, you can feel more, it's a kind of taste, you can say a pleasant taste. Now not exactly all the waters will having the same amount of the minerals or same amount of the gases dissolved over there, because the types of water will be different from one region to another region. Because for example, okay, we'll come that later on. pH, let's see what is pH. pH stands for potential of hydrogen. It refers to the hydrogen ion concentration in a solution. It is the measure of the acidity or alkalinity of a solution. The pH value ranges from 0 to 14 on a pH scale. Anyone is in chemical engineer with me, or anyone deals with RO system? or water treatment? Anyone with me? Mr. Abdul Rahman, do you deal with this?
Yes, we did.
Do you deal with this? Anyone else? No?
We only install, sir.
Sorry, Umesh.
Our previous project, we installed aeroplane.
I could not understand. You can come back again once again, please.
We are installed this aeroplane in our previous project
Okay, khalas.
for 1 year ago.
But you're into the technical team. I mean, you know the designing for that arrow.
We are technical team, sir.
No problem. Okay. So now pH stands for potential of hydrogen. So we can do this test by having some things, some meter and all this. Basically, this is done by a chemical engineer, but I'm just as an information why I'm giving you is this, because we are dealing or we will be dealing with this. I mean, the flow, I mean, the medium as the fluid as this water. So we need to have some information what exactly is a water and different modes of the water, different kinds of the water. So we know just as overview that is hard water and soft water, and we don't know about what is TDS, total dissolved solids, what exactly is that, and we don't know as what as pH or potential of hydrogen, because it is very important to know. If you know that, you can know, okay, this water is like good for human and this is not good, because the value ranges. Whenever if I do that test, if I take example, I've collected a water in a glass and I do the test, and in that test where I'm trying to find out the potential of hydrogen, that how much hydrogen is being present into that. So if I get the range between the scale measures on 0 to 14 and 0 to 6 is what you can say this is acidic. I mean the values which goes, and that is very hazardous and very dangerous, not accepted or not recommended to consume that water. And the normal ranges water, I mean the normal range water refers to the rainwater. I'm saying it is natural water ranges of the pH of 6 to 8. That's the best water you can say. But nowadays they are saying 6.5 to 8.5. That is as per the WHO, that is World Health Organization. Okay, but now after 8 we do have till 14 also. But what happens if the pH level is more than 8.5 or something? So that is alkaline in nature. Alkaline we can proceed. Okay, till 8.5 the water is okay and it's safe. That it causes no harm on the body of the human and all this. We can go with 9, 10 also, but what happens after 8.5 or 8 potential of hydrogen, I mean the pH when is measured on the meter, you'll be sensing a bitter taste in that water. Okay, but below 6 and all this, that is acidic. For example, 5 is slight acidic, 5 is more, 3 is more, 2 is more, 1 is more and more before the previous, 0 is the extreme, that is highly acidic water. You can say as treated as acid only. So now that again depends upon the type of the rock from where the water has been passing by. Okay, we'll be coming to that. Okay, so once again, so pH potential of hydrogen stands for, and this ranges from 0 to 14 on a pH scale. The pH of natural water varies from approximately, this is the rainwater, 6 to 8, and depends upon the type of the rock which passes through it. That means, for example, whenever the rain occurs, what happens? Where does the water goes? In the ground, yes or no? And below the ground, we have a number of things. We don't know what was there. If we are on archaeology, we can say there were a number of things over there. There might be some debris, some dead bodies, or like ancient times, I'm saying. For example, a number of things over here, rocks, it might be there and something, it was a salt and all this number of things over there. So that's what, for the moment we extract or the moment when the water is being touching the rock and passing by, for example, it's a lake. So lake is like on the surface and it moves on, or a river, yes or no? In some areas, it might be as low as 4. Example, due to acid rain. So acid rains do occur. If there was acid rain, then the natural water might not be having this value. This would be 4. And that is again not recommended because it's not good for human body. The best water is this 6.5 to 8 as per now WHO, or 6.8 is 6 to 8 is the range. The pH scale, which ranges from 0 to 14, measures the acidity and alkalinity. How I'll say you? Acidity increases as the pH value decreases. As I said below, it's going increasing the acidity. The value decreases, the value increases, it increases the alkalinity. Okay, and alkalinity increases as the pH value increases. So you can see over here, pH less than 7, is solution is acidic. That means water is acidic, or a solution here refers to the water. Here pH greater than 7 is solution is alkaline. And you can see this green, as you can see, it's a safer side. But here, WHO people say 6 to 8 or 6.5 to 8.5 is the best water where a human can consume. Apart more than 8.5, you can see the different colors. This is the most dangerous water, acidic. And if you want more, this color has some denotions. Like example, this consists of some debris under the, what shall I say, the ground. So like some bodies and all this. So that's again the water's been passing by. So we'll be having this. This is, for example, some other thing. This is some other thing and all this. Okay. This is the safest water, what we say. Okay. So this is generally done by a chemical engineer, and we'll be seeing the total dissolved solids also. That is nothing but how much amount of the minerals has been there. That is also not safe. So we need to check that as per the parts per million, that is ppm. We'll be seeing that also. Now, what are the sources of the water? From where we get the water? Dams, river, lakes, wells, borewell, etc. Again, the main source is what? The rain only. Yes or no? But still, the pH changes because of what? As per where it got stuff, absorbed, and from where we are dragging the water. Okay. So that's again the sources of water. From where we get the water available is what? These are the things over here. So there are two types of water, hard and soft water. So in general and common, we do have two types of water. What we know is mostly one is hard water and other is soft water. So what do you mean by hard water and soft water? Let's see it now. Hard water is something, and what is hard water and what is soft water? So in general, if I talk here about what is hard water online, can anyone say? In short, I can say hard water is a water which does not gives you a lather readily or easily available, isn't it? When you apply a soap, or when you apply soap and you have added that soap to uh, the hard water and you try to shake that up, it will not give you the rich lather or the readily available lather. Okay. Whereas you deal up with the soft water, if you add same amount of soap with the same amount of the water, it will give a good amount of rich amount of lather, isn't it? So what is the reason behind that? Why here I'm getting a rich amount of lather and here no? We'll be seeing that because there is some extra things over there. And what is that we'll be seeing? Because minerals in certain quantities, okay, it's if that high is also not recommended. Like we know this in simple and general words, we know some information that because if we use hard water, I can see one thing that is nothing but I can see the scaling factor or the salt content around the container. For example, if I'm having a plastic container or a bucket in which I'm like always using it to collect hard water directly extracted from the ground or bore well. So while continuous using, you can see the scaling over there on the surroundings, white color, yes or no? For example, you can see in very common, that is nothing but you can see in aquarium. If you have like aquarium and if you have this like we need hard water for the fishes over there. So again, you can see on the surroundings, you'll be having this what? The kind of mark over there, white color. There is nothing but the salt content or scaling what we say. Yes or no? Yes or no online? So there's some problem with my camera. Just a minute online. Okay, so we know this. So, but let's see more in detail. So first of all, what is soft water and hard water? We're seeing now. The soft water contains little or no dissolved solids. That is talking about TDS. That is total dissolved solids. By seeing this only, you can say the water is hard or no. Okay. So how we can see this? By again measuring with a device in which you get the TDS value, and by that TDS value, you can say yes. If the value is below the range, then it's a soft water. Above the range, then it is a hard water. Okay, and that we can measure in terms of parts per million. Also, that is ppm. Now, the often color for the brownish or yellowish. Now, what is it? Often color for the hard water and soft water, it is brownish or yellowish. Yellow is mostly for the hard water. Okay. Next is the hard water, on the other hand, will have a high calcium. So that's the main content over here, in which hard water is rich of calcium and manganese. That's why you can see, I mean, the salt over here, manganese content, manganese salt content over there. So this both things is more in quantity. So I can say that is rich in, I mean, these two things, then it becomes a hard water. So both the things in a range, that's okay. Okay, but in soft water also, we do have the both things, but here the content is more. Okay. So that's why it becomes hard water, and that is the reason it could not give you a rich lather because of the salt content and a high calcium present in that water. So hard water does not form lather readily when has shaken up with the soap solution, whereas the soft water easily does. I hope you're getting everyone. Yes, please. Okay. Why? Because
Yes, sir.
problem from my side. Something is fluctuating. I mean, my internet and all this. Just a minute. Sayansh, Mr. Sayansh, please on your camera.
Just a second.
Yeah, please do it. Yes, we can see you, Sayansh. And
Yes. Hello, sir.
yes, we can see you, and I hope you can see me and you can hear me. And the rest of
Yes.
you guys, all your colleagues who is in the batch, okay, they are already with us doing. And today is the third lecture, okay, but still in the basics, no technical thing gets started. Today is the thing. We'll be discussing some technical things over here, okay. Just try to cope up. Cope up. If you have any kind of doubts, you can unmute your microphone and get back to me.
Okay.
Coming back to the topic, so I was discussing about the hard and soft water. So we have seen 3 points over here. And the fourth point is the table below shows or subdivides the hard and soft water into several classes depending upon the hardness. So if the value in this hardness, I will be coming back to this. This is defined in ppm, that is parts per million. If you get this values when you measure, we carry out the water, and if you measure, if you get the value in between this, then how it is classified as soft or hard or moderate hard or extremely hard, we'll be seeing that. Okay, so we'll be seeing that table, and we can identify that this water, if I'm getting this value, whether it's soft water or hard water or many classifications in that, we'll be seeing that table. Now, just as percentage means of 100, like example, we know this in since our school days, or we can say our like graduation days or masters, whatever we have done. So we know that the percentage what we get in terms of 100%, isn't it? So here, but here will be measured in terms of 1,000. That's why, sorry. So parts per million. Million means 10 lakhs, I can say. Yes or no? Yes or no? Only 1 million is 10
Yes,
lakhs.
million. 10 lakhs, sir.
Right. So parts per million or ppm stands for parts per million, needs out of a million. So we are here to find out in 1 million what is the part in that. Like example, in 100, 60% or 70% we take out of 100. Like here, one part out of 1 million, we'll be seeing that. Okay, that is being measured of a device in which we can find out, and we can say this is hard water or soft water. Usually describes the concentration of something. Concentration of what? Calcium and manganese salt over here in water or soil. 1 ppm is equals to 1 mg, milligram of something per liter, or 1 milligram of something per kg soil. Ignore this, one and the same is saying in terms of soil and fluid. So now if anyone carries out water or a fluid and tries to measure this, if you get the values by that device within like the 0 to 50 ppm, okay, so you can say this is classified as a soft water, and this water is recommended to use for the cooking and drinking purpose. Now, moderately soft would be in between 50 to 100. Again, this can also be used 50 to 100. Slightly hard, the value is 100 to 150. And now this can be used for washing and cleaning, not for cooking and drinking. Moderate hard is 150 to 200. Extremely hard, like very high calcium content in manganese salt, then this is above 200. So that is very, very, very hard water, not recommended for drinking, because you know this water has a very good properties, minerals, which is very essential for human body. Within the range, that is okay. Okay, so the best water I suggest you is nothing but the municipal water, what we get. Even the packaged water, what we take and drink in the outside, it's not safe, it's not good. If you see the process, will not drink that water, honestly speaking, right? So that has been treated water. They extract all these things over here. It's just a plain water without any, what shall I say, effects to the body. I mean, in a good manner. And it causes again some more disadvantages to the body, discomfort, like many things, organs will be affected in future if we have that continuous consumption of water. Okay, so not to use all this kind of thing, the best water is nothing but the municipal water. Within range will be having, below 100 will be having the ppm. Okay, that's clear, everyone. Just simple and basic information about the fluid what we are going to use or what will be used in the plumbing industry. And the matter is solid, or sorry, liquid, and that is a water over H2O, and we have learned about and appliances. So we'll be seeing the plumbing fixture. Like I said from the day one, I have said you two things over here. Like I've shown you the picture and I said that kid was collecting water from laboratory and WC was behind it. And I said that the both are plumbing fixture, isn't it? But what exactly in technical manner a plumbing fixture is? In short, I'll say you, plumbing fixture is nothing but a fixture or an exchangeable device, I can say, which exchanges the water in the sense which demands water at the same time. At the same time, the water needs to drain out. Yes or no? In simple terms, I'm saying you, like example, the same thing. Laboratory demands water for the cleaning of the hands or washing face and all this, right? But at the same time, the water which has drawn out of the tap, it needs to drain out, isn't it? And that is a medium. What is common in between? A fixture. Yes or no? Online. So a plumbing fixture is an exchangeable device. It's exchanging the water, you can say, in and out. Device which can be connected to a plumbing system. You know what is a plumbing system? It consists of pipe, fittings, accessories, and number of things like tanks, pumps, all this. Yes or no? So this is connected to plumbing system to deliver and drain. That means deliver means to supply and to drain out the water. So this is a plumbing fixture. So now very first picture, what we're gonna see in the chapter number 1, that is WC in common, but in technical term, we call it as a water closet. WC abbreviation is water closet. Now in this also, we do have number of variation or classifications, I can say. Like we do have first, what you are seeing is in what? Western, East. Very good. Western, right? So this is Western WC, okay, or European, you can say. Okay, so this is only WC over here. Don't keep in mind this is something else. We'll be seeing it later on. This bowl, what you're seeing is a WC. Okay, and this WC demands cold water. Now, what is the reason we are discussing about these pictures over here? Because when we come across the designing, for example, if I'm dealing with the designing or the doing the load calculation for the pipe sizing or the routing, now one should know that what fixture demands what kind of water, like hot water or cold water. If it demands that, then as per that, I need to count the fixtures in and I need to proceed the calculation as per the needed. Okay. So this demands cold or hot online. I'm not talking about this flushing mechanism and all this. So this demands cold or hot online.
Cold.
Goes for VIP.
Cold water.
Inside we'll be having a shower. So cold water. Okay. So just for the WC, not for the tank. We are not discussing. Okay. So WC also demands only cold water, always remember. Okay, so this is one European WC or Western, just now said. So the second classification is Indian or Arabic, you can say. So this is how it looks like. Again, this also demands cold water. Again, just for information, one more time, just showing you this thing so that you know that what demands what amount, what kind of water, so that we put into this and we can proceed up with the load calculation. Third is universal. This is something not common. This you can see in like public places, I can say, especially I can say in some 5-star or 3-star restaurants or 7-star restaurants, I mean hotels, and I can say in airports also. Why? Because this is a combination of both. If you see, this looks like European or Western, but again, it can be used as Indian or Arabic. Can you see these pedestals over here online? So it is as per the need. For example, in a restaurant or a hotel, someone comes to stay, for example, a 5-star or 7-star hotel. So they have this because as per their habit, one can use as per their nature of call, they can use it over here. Again, this also demands only cold water. Okay, so this was about the WCs. The next is system for the WC and urinals, flushing system, I mean to say. So this is nothing but a flush tank, I can say, but this is a gravity flush tank. And you know what is a gravity flush tank? By means of gravity, it works. And a standard flush tank, as per IPC, says that it delivers or it drains out 1.6 GPF, that is gallons per flush. You can see it over here. Can you online?
Yes, sir.
Yes, sir.
1.6 gallons per flush. That means this tank standard has a capacity to hold of 1.6 gallons of water. That means I can say in one flush, we are draining out 1.6 liters of the water. And the water which is being used over here is not a soft water. It is recommended to use a hard water. Okay, why? Because that water is not for use. So we can use it for the flushing purpose or cleaning of the houses. Soft water only for drinking and cooking purpose recommended. Okay, so not recommended for the flushing purpose. Okay. Now, how it works? It first of all, say you the moment we press this knob, this chain lifts up, and here vacuum creates, and from here the water gets into it by means of pressure. And what happens by means of gravity pressure? It comes and do the effective cleaning or the flushing in the WC. And this has been connected to only WCs, not the urinals. Don't get confused. Have anyone seen flushing tank connected with the urinal? Anyone? No, na? Yes, online. Has anyone seen? No, na?
No, sir.
No. So this just with the WCs over here, and this how it works. I'll say you. We'll be having one knob over here. This is float valve function. You can see. But before that, this is float valve. Yes or no? And you can see this is
Yes, sir.
going down. The moment it's going down, it opens from over here. You can't see this. I'll show you the cross section right now. It opens from it, and this would be connected directly to one pipe from where the water gets entered and falls into this. And the moment the water has been filling the ball or this float valve, it lifts up and it comes in like exactly this 90 degrees, and it will come in front of this. So it will cut the water supply or water entering into this tank like this. Can you see this? He is pressing this, and you can see a gap. When this completely lifted like 90 degrees, this piston kind of thing, it will come in, stick to it. So there will be no water supply from here. The moment it goes down, this will be completely open. This, can you see this online?
Yes, sir.
Right?
Yes, sir.
So this is how a float valve functions. Okay. So this is the main mechanism over here. And this holds up 1.6 gallons. And the moment we press this knob, the water gets over here, and it has effective cleaning in the WC. Always remember, gravity flush tank or the flush tanks connected with the WCs, not with the urinals. Urinals, we are having something else. We'll be seeing this. So this is a first and very common. What we see in our houses is also nothing but a gravity flush tank, which delivers 1.6 gallons per flush or 1.6 GPM. Now this is one more flush tank, but this flush tank is different from this previous flush tank. So this is
Excuse me,
flushometer.
Sir, what is the function of this fill tube? Yes. Can you just please go to the previous picture?
Yes.
Here, this WC tank.
This is actually not exactly gravity flush tank. We don't have this much of things. This fill tube and all this. Here we'll be seeing this. In this, the same mechanism over there, but some more extra thing. In this, if I say you, okay, I'll just show you. Wait just a minute. Anyone came across this tank? I mean, flushometer tank. Anyone has any idea how it works? Yes, anyone? No? Yes.
Sir, it is a refilling valve and a ball that can close and open the water supply, and one valve which can, when we turn the flush on, the water goes to the flush, and that automatically with time it's off. बंद हो जाता है धीरे-धीरे, and then tank you can go for the refill.
Okay. Not exactly. I'll say you. ये देखिए image. See this image, everyone. This is a flushometer tank. Okay. This has the same capacity of 1.6 gallons per flush. It holds the same amount of the water. But here, inside, if you see this is called as air accumulator. And this is again connected. This one knob has been connected to this air accumulator. This is actually a piston, which is filling with air, compressed air inside. Okay. And here is the water supply inside into it. The moment we press this knob, this will be not acting on this lever, and this lifts up and releases the pressure over here and water. So here what happens is both the things, water and air, both comes out, and this will be very effective when compared with the normal gravity flush tank. So this is the most, what shall I say, the difference between this both tanks over here. This can also be used, and this is using right now because just to effective cleaning, not wastage of the water again and again. And one more thing I can say, this is expensive when compared with the gravity flush tank, okay, because of this system over here. Okay, and yeah, that's the same. Okay, so this is flushometer tank. Always remember. Okay, flushometer tank is also a same kind of tank used for what? The flushing purpose. Inside you have is air accumulator or piston, someone says, that releases air. And so air and water at the same time, so more effective cleaning. Okay, so now this is something what we gonna use with the urinal. What is this called as online?
Flushometer valve.
Very good, flushometer valve, right, or flush valve. So now this would be again connected to the urinals, and you know this, the moment we press this lever and all this or handle, we'll be getting this. We in this also we do have number of things over here like manual and automatic. Right now just manual. So you can press this and you'll be getting a certain amount of water. For once we are done with the urinal, we need to press this because this is manual, and it releases some amount of the water unless and until we close it off for the flushing of the liquid over there, okay, in the urinal. So always remember WC or tanks, WC with tanks and urinal with the valves, okay. But one more thing, nowadays we are having flushometer valves connected to WCs, but not flushometer tank, flushometer valve I said. Only this knob you'll be seeing, and that is what? Concealed. Yes or no, Tarun? Dealing with it or no?
Yes, sir.
Anyone? Umair, I think you
No,
both are
sir.
working with this, right?
Yes, sir. I work in 2 projects.
That's what flushometer valve I'm saying. Are you aware or no? WCs. That is more effective and very huge amount of water. Anyone has any
Yes, sir.
idea? Anyone on site? Good plumbing? Anyone with me? The site engineer? No one?
I am draftsman.
You are working, Mr. Umair, as a site engineer?
Yes, sir. I am working as a mechanical draftsman.
Okay, khalas, no problem. Okay. So I think, but you have an idea because you have seen in the drawings, I guess, flushometer valve, right? And the detailing. So flushometer valve, I'll show you. If you want, I have some catalogs also, I can show you that. So, but very most important thing, point to be noted, you should note this. There's a huge difference between flushometer tank and a flushometer valve, or a tank or a valve. Valve has 3 times more amount of water extracted and drained out for the cleaning purpose. But you can't compare this valve with that flushometer valve. This valve is only for urinal. Now you don't get confused that this valve is which is connected to the urinal, which is having a low velocity and a low GPM, okay, or a less GPM. And there, the valve which is being installed with the WC, it's having a very huge amount of water drawn at the same time, okay, and it is a very huge velocity, almost 3 times of the water required of the normal gravity flush tank. That is 1.6. For example, we know that it demands 1.6 gallons of the water it drains out, right? Almost 3 means I can say how much? 4.8. Yes or no, online? Right. So make sure when you are seeing flush valve with the WC, it's not this valve what you're seeing with the urinal. This is designed on a low velocity system. That is designed on a very huge velocity system or with a very huge amount of the water over there. Okay, because of the attendant. Okay, so this is the flush valve and that is also a flush valve. Don't get confused, but this is with the urinal. But if you're seeing any flush only a valve just to press in the WCs, that is what, again, just don't compare with this and that. So what is the main thing I'm trying to say here is that when you're dealing with any kind of designing, you need to know, everyone, that what is the flushing mechanism in the project. For example, we need to know that the flushing mechanism in our project is by flush tank or flush valve. If it's flush valve, you need to be very, very, very careful because it demands 3 times of more water. For example, I have not checked this and I have just moved on with the calculation by considering or without seeing or without getting the information from the main contractor, and I have done as per the tank, then it would be wrong because I have done a big blunder because it was 1.6 I have done. It's not actually 1.6. It draws very big amount of water over there. And that has been directly connected to the water supply of the pipe in which water is always available. Okay, but here this tanks act as a reservoir, like holding up water and then flushing, isn't it? But they're directly connected to the pipeline. Following online. So just please make this in your mind, note it down. Because we will be first thing is in the designing load calculation of the pipe, we'll be checking the first thing is this, that what kind of flushing mechanism, flush tank or flush valve. Flush tank, this values, flush valve, that values. Please online, note it down. We'll be inshallah seeing that. Okay. So as I said, now this is a flush valve which has been directly connected with the WCs. You can see here is the main pipe, or the water supply pipe will be connected. Here you will be having this cross-sectional area. You will be having a kind of knob over here or here. The moment you push this, it will release a huge amount of water for the cleaning of the WC. You can see the plunger or the spring over here, which adjusts this over here. Okay, so this is one more flush valve connected with the WCs, and this is a flush valve connected with the urinals. Okay, next picture of the plumbing is nothing but a laboratory. Okay, so laboratory demands what online? Cold water or hot water?
Both.
Yes. So always remember, whenever we are dealing with a laboratory or we have come across the laboratory, I need to design this laboratory and I need to do the calculation of laboratory on the 2 things. That means this will be demanding cold water as well as the hot water. Yes, please.
Sir,
yes, please.
Regarding this flushometer valve in the WWC, where the water will store? Where do we have the storage tank?
Okay. As if now, I'll come to that. As if now, just remember, directly connected to the pipeline. and demands only cold. Okay, for the flushing only cold. Why I'm saying you, because we are
Okay.
starting from the basics. Inshallah, as we move on slowly, we'll be coming to the systems also. Okay, Fahad.
Got it. Got it. Thank you.
Right. So
Thank
now
you.
this
Thank
is
you. Thank you, sir. Thank you.
Welcome. So this is laboratory, everyone. So one more picture. So laboratory demands cold and hot water both. Okay. So this needs to be calculated or designed on the basis of that. It demands both hot and cold water. Okay. So this is a laboratory, nothing but wash basin. This is single, and this is one more laboratory. This can be installed anywhere, but this can be installed in the living area. For example, if it's a hall or something, or where people is eye contact to this, like example in a hall and all this, then same laboratory, but here is with the pedestal. This is called as pedestal. This one, what you're seeing, a kind of leg. Here it's open, so it does not gives you that pleasant look. So that's why this is one more laboratory with this piece that is called as laboratory with pedestal. Like example in the parking area, or you can say we are having some kind of garden or lawn where we sit, and it gives a pleasant look. Or like example in the villa or the project, we are having a hall, and then side by we're having one laboratory. So it's recommended to have this kind of thing for just for a interior purpose, in short. Okay, but this also demands what? Cold and hot. All the laboratories demand both. Yes or no? One more is what? This is called as laboratory tray. Now, what is laboratory tray? Laboratory is laboratory, demands both cold and hot. Laboratory tray is something in which multiple people can be served. Like example, I can say you in function halls, like number of people will be served, or in shopping malls and these kinds of things, like number of people can be served. Yes or no? At the same time, online. Number of tabs. Yes or no?
Yes, sir.
Laboratory tray. This next is again a bathtub. So what does this demands? Complete hot or complete cold, or cold plus hot?
Yes, sir.
Both.
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 Both, sir.
Both, right? So this is a normal bathtub. What you're seeing, one more picture which demands cold and hot. Okay. So next is under this, we have one more category. This is called as whirlpool bathtub. And this, what you're seeing, is called as a pressure points, from where a jet of water comes
Jacuzzi.
out. Sorry, jacuzzi. From where a jet of water comes and hits to the body, and it acts as a massager also. This you can see in the sauna centers, gyms and all this. Okay. And you can see there is one control panel over here from where you can increase or decrease the velocity or the intensity of the water. I mean the cold or hot, how much you need as per your convenience, or jet of the water and all this. Okay. So this is whirlpool bathtub or jacuzzi, you can say. Again, this also demands what? Cold or hot, or both?
Hot and cold. Both.
Very good.
Both.
Right. So this is one more picture. Next is in shower. This is called as head shower because it's installed above the head over here, and this is wall mounted. I can say this is fixed. I mean, only this can be slightly tilted. Yes or no? So this is shower, and this would be generally installed at a height of 6 to 7 feet as per the region, because as per the person's personality over there. Okay, in that specific region. So this is head shower over here, and this demands also cold and hot because it's just used to have a shower or a head bath. So this demands again cold and hot water by means of a mixer over here below. Next is this is hand shower. I can say this one, you have some flexibility. You can see there's one hose pipe connected to this shower. Yes or no? Online. So that means it has some what clearance on the left, right, above and back side. Yes or no? But I'm not showing you this shower. I'm trying to show you here is the laboratory tray. This is called as laboratory tray. For example, this is actually a bathroom over here, or this can be a hall also, or a big bathroom. So now you can see this is the glass partition over here and here and here. This is completely glass. You can't see it over here. That's why with the image, when it's taken from over here, you can see it's a glass over here. And this, if you see, it is having a slight slope over here. This is laboratory tray. Okay, when the water is being drained out after bathing, the water goes in this direction and drains out this from this drain. Okay, we'll be seeing this, but here is laboratory tray, and this is one hand shower, I can say. Okay, so two things over here. And next is what? Bidet. And one more thing, online, I think you are getting one new concept or one new thing. I don't know anyone is aware or no. One is I'm seeing right now is rain shower. Anyone has heard about that rain shower? Anyone?
No, sir.
Google it. Rain shower, nowadays they are using it. Now there is having a huge amount of water into that. And the panel of that would be almost, I can say, 6 to 8 inches, this big, width and length. And that would be, when you stand under that, you feel that you are under rain. Getting my point? It's a rain shower. Same thing, but again, that shower remains shower, whatever it is. Okay. But there is one thing. What? The GPM will be increased.
GPM increase.
Yes or no?
Times.
Right. So Q increases over there. So change in Q. Okay, remember that. Now this is a bidet. Now what is bidet online? I think just now you said, Umair, you know this. This is right beside the WC. Yes or no?
Yes, sir.
And this is bidet. Bidet is again also called as a baby cleaning. Yes or no? Used for high-class villas, and this can be used for handicapped people also. This is right beside the WC, and this is only designed for cold as per the region. But this, as per IPC standard, this should be working on cold and hot both. That's why you can see two knobs over here. Always remember, right hand side of us cold, left hand side of us will be hot water supply. Okay, so you can see this is cold and hot, whatever it might be, and this is used for the cleaning purpose. Like example, someone is handicapped and all this, when they are done with the WC and all this, they can sit and you can see a shower, a jet of shower sprinkles it, and cleaning would be done. And from here again some amount of water, so that what happens, this would be flushed off from over here as a kind of drain over here, you can see. So this is in high class villas, baby cleaning, and high class villas just for the need, and again for the handicapped people, this would be seen. Okay, and always remember, be very careful when you're dealing with this, and you need to first of all take permission that if they are saying it's gonna be with hot and cold, just have that in writing, because if you said only cold, you have given hot and cold. If something goes wrong, then it will be problem for us, right? Then they'll be questioning us, then why you have done this. Okay, so very careful. Like in European countries, it is recommended, because as per IPC, I can show you we are having two values, hot and cold. So it makes sense that it can be working for hot, it can be working for a cold. Yes or no, Umair?
Yes, sir. Yes, sir.
Umair, I think because you have done this, because Umair is a draftman, he is much aware of this, I hope.
Yes, we also have in current project.
What do you have?
In our current project, we will install this,
What kind of project is that where you have installed?
this high-rise building, sir.
No, application, residential, or what was that? Municipal project? Or
No,
what?
hotel, Mahesan Hotel, sir.
Hotel, okay, that's what. It can be used in hotels.
50 floor.
No problem. Or it might be a VIP room, something over there. Drain. Now this can be a drain is a drain. Now if you see this unwanted water to be drained out by means of a drain pipe or a waste pipe, so this would be the thing from where the water gets in and gets out of the specific area. This is installed in the floor, so I can say this is a floor drain. In the bathroom, we have just now I've shown you in the lavatory tray, that is what a bathroom drain you can say, or a floor drain you can say that also. Okay, but drain remains same, just to what vanishes out the unwanted water in that particular area. Okay, the flow drain again. Next is urinal online. Just before proceeding with urinal, just wanted to show you what is this connected with the urinal. What are these three above? Flush
valves.
Right. Yes, these are our three urinals over here. This is for kids. That's why it's installed somewhat below. This is for the adults. So okay, again, this demands only cold just for the flushing purpose of the liquid. Okay. Next is what? The kitchen sink. The kitchen sink is mostly made up of stainless steel. And in this video, of two categories, single bowl and double bowl. That means what? Single bowl generally we use for residential, and this commercial will be having like hotels and all this. Two bowl, nothing but one more a big bowl over here, and the size would be more higher because the usage or the utensils used in that particular application or that area is higher. That's why store and to wash. And this, and you know this, there are different ways also they wash. Like example, they collect water somewhere and they wash, and they again just dip into it, take out. That's different thing. Okay, but here this is a stainless steel. Okay, 316, and this is how a kitchen sink looks like installed on the kitchen platform in the kitchen area. This demands what? Again, you can see two knobs, right and left. I can say what? This acts as a mixer. So what I can say? Both or only one?
Cold and hot.
Both.
Demands both. Cold and hot. Okay. Next is a service sink. Service sink again. Anyone can say that? What is a service sink? Umair, what is service sink?
No, sir. Maybe in this
for drain out dirty water or cleaning dirty thing.
Janitor sink. Okay, there is one more sink called as janitor sink. This is again, as you said, clean out for dirty water or something. It can be used, as you said, it can be used in laboratories and all this. There is one more sink called as janitor sink, and that sink is like a kind of mop where he carries out the janitor. He mops that for the particular area, and it takes carried out all the way. That is the janitor sink over there. Okay.
Janitor sink, sir.
Sorry.
This is janitor sink, sir.
That is, yeah, that's what I said you that. Janitor sink is one more other I said you. Okay. So this is ablution tab area. We have seen this ablution area and these are ablution tabs. This should be designed on the peak demand. Okay. So just for your information, peak demand means I can't go with the probable demand. Sayansh, for you, maximum when we deal up with the probability, whenever we are dealing for the design for the plumbing in residential. But in some areas, we need to go for the peak demand. This is one of that. There is one more or two cases where we need to think and go for the peak demand. Following Sayansh, next, electronic flush valve. Again, we got flush valve, but this is one new thing over here. This is electronic.
The sensor, photoelectric sensor, a movement sensor.
I can say yes, electric sensor. And what is this? A sensor, infrared sensor. Yes or no?
Yes, sir.
Now, how it
Yes,
works?
yes, yes,
Now,
sir.
how it works, I'll say you, for example, if this is installed on a urinal, what happens is over there, for example, if it is installed on a urinal, example, someone came and they are done, and the moment they are moving in manual, we need to press it manually. Here, no need to do anything. The moment we come over there and when we are done, first of all, the moment we come over there, it senses the human body temperature and it is ready to release out the drain of the water. But he waits unless and until we moves on from there. And you have seen this, the moment we step back, once we are done, it automatically delivers a certain amount of water for the flushing of that, for that liquid. Yes or no?
Yes.
Yes, sir.
So this is one more thing, and this is again somewhat money-wise, I can say this is again somewhat expensive when compared with the normal flushing valve, because this is like having some electronic devices and all this, and this is like with sensors, and it works with like I can say with directly with electricity or with the batteries also. What you are using right now, Fahad, with batteries or with electricity?
Sir, with electricity.
True. We do have with batteries also. Anyone not seen that?
No, sir.
No, sir.
We are having batteries also nowadays. Let's come back to
Actually,
the,
we have recently installed in one of.
where? Share your knowledge.
Actually, I have recently installed this electric flush tanks in
Okay.
one of our project in Riyadh. This is a hotel, 4-star hotel.
Okay.
So this was the demand of the Ministry of Tourism that in the common toilets they need electronic flush tank.
Okay.
So I have installed Yani myself. So we just provided the electrical connections, permanent electrical connections, and we Yani the kind of the flush tanks we installed here, it can be used by manually or it can be used with IR sensor. Yani.
That's great. Okay. Now the thing was why they have gone with one more option like batteries. For example, if there is any maintenance for electricity and all this, or there is no power, then in
Yes.
that case, so that the batteries will be
Yes.
working. Okay. Just for your information. We got
You
it.
can use manually. Yani. Yes.
Yes. And one more thing I'll say you. For example, not manually or both. I mean, your options, like you said just now, Fahad, it can be used in this or that. And especially with if you talk with handicaps also, there is one more option. Inshallah, if I have that catalog, I'll elaborate that more. Okay. So now coming back to next. Okay. What does this demand online? Cold or hot?
Cold.
Flushing
Cold
cold.
water.
Only cold. Okay.
Cold water.
Only cold water.
Only cold. So what are the advantages of this? Can anyone say? There is hygiene concern over here. Okay. There is nothing to touch. Okay. We don't know, like example, now, right now, the pandemic is going on and all this. It says that if someone touches this, like example, some chronic disease or hazardous diseases will transfer from one person to another. So there is no chance of this. So this is the best thing I can say. And second thing is what? It is savior for the natural resources. For example, water is a natural resource. Yes or no? For example, if someone forgot in a manual, then water is continuously draining them, isn't it? But here, certain amount of water
Yes.
can cut off the water.
Yes.
Okay. For example, if you are having kids and all this, if they have on this, then continuous drain of the water. So we can use this not only with the urinals, we can use this with, or we are using with this what? One more thing, laboratory. I think you have seen the moment we place this hand under the laboratory, it senses the human body temperature and releases certain amount of the water for the cleaning of the hands. I think you might have seen laboratories online. Wash basins. No? Anyone?
Yes, sir.
Yes, sir. I've seen.
That's
Sir,
what.
we are using IR tabs. Yes, we are using.
That's what.
Yes, we use tabs.
That's
yani,
what
which
I'm saying.
which
But
works with
what is the
sensors.
what is the difficulty Fahad over there? Disadvantage? Advantage I can say, but there is one more disadvantage also. This is very best for a urinal, but if I talk about laboratory, I'm having one advantage and one more disadvantage also. Advantage is that it is recommended first of all to use with hospitals. Mostly you see this kind of things in hospitals because, for example, we don't know what kind of patient is suffering from what kind of thing, and there are a number of people who are visitors also. Okay, and the doctors maybe if there's a common thing. So what happens? It should not transfer any kind of disease from one person to another. So this has like decreased the maximum thing or the chances for transferring of diseases from one person to another. But it's okay for the urinal. But there is one problem again with the laboratory. Laboratory is also okay. I'm getting the water, but as per now, the mixing cannot be done into this. I mean, laboratory demands cold and hot. I can only give the logical connection with cold. I can't do the mixing over here because with this, I have not got so far as a mixer. Yes or no, Fahad? Or we got right now?
Yes, sir. Yes, you are right, sir. This is a problem.
This is the problem, right?
Either you need to allow cold water or hot water.
Or only hot water. Only one.
Only one option.
That's
Yes.
one. Okay.
One option available.
This is the main drawback of this. But we are using it and it's really good, isn't it? Because you're saving many things over here. You're like hurdle free by touching this, and you're not wasting natural resource also, because only certain or limited amount of water, I can say 1.6 GPF I think I will be getting, or 1 gallon I think, not more than that. Yes or no?
Yes.
After that again cut off the water, again it will be loading. Okay, so this is the advantage and one disadvantage. Let's move on with one more plumbing picture. But why we are doing this plumbing pictures online? Anyone has any idea why we are discussing is this? Because if we come across this picture, one should know, because we'll be having maximum pictures into all of the projects. It's not necessary that what are the pictures what we are seeing I'll be getting all in one project. No, because drinking fountain we don't get in residential, but we get in some commercial projects. Like example, railway station, airports, railway stations. Yes or no?
Shopping
malls. Yes or no? We'll be getting this. So this is what a drinking fountain. So drinking fountain, again, I'll say you, we got one more thing, drinking fountain, what I've recently seen. It was a kind of sensor over here. And again, the moment you put, it is a jet of water again comes out and one can place their mouth or put the hand and drink the water. Drinking fountain again demands only portable drinking water. That is a soft water and a normal drinking water, not chilled water, normal water, not hot, not cold. Like example, I can say 10 degrees. What we receive from the municipal. What we receive from the municipal is 10 degrees centigrade. Normally, yes or no?
Yes, sir.
So this I can say. So 10 degrees you can say, not chilled, not hot. And for the serving purpose for the people. And again, to maintain the hygiene, you'll be finding this in the commercial places, like just now we have discussed, like airports, shopping malls, and railway stations, these kinds of things. And this will be not be having any container. Again, why? Because just to what? Maintain the hygiene or concern for the health of everyone. Because if someone is ill and all this, again, that should not transfer to any person. So again, when we are having this, we need to count in for only, it demands only cold water. Getting my point? That is why we are going in a step-by-step manner, and we are seeing this plumbing picture, that what does this demand and where it can be used and what is the purpose to be used. Okay, or what's the purpose to be used to fulfill what purpose. Next is what? Cooling tower. Okay, I forgot one thing in the very first session. I'll say you something. We have just discussed what is a plumbing. Can anyone say what is plumbing? I said you, plumbing is something which
that conveys water.
Which needs exchange of water.
And it can serve to multiple applications. Yes or no? It might be any kind of application. Yes. I said you. Plumbing is something, right? So here, many people have a confusion that if you are dealing with plumbing with the bathroom or the kitchen areas, it's only plumbing. No, it's not that plumbing. Even this chilled water piping, if you are aware of HVAC, vapor compression cycle. I hope you guys know what is vapor compression cycle.
Yes, yes.
Right.
Sir, we know.
We do have this air-cooled chillers connected or water-cooled chillers connected with that. So the pumping of the water happens. So the piping and the pump, that all again is a part of a plumbing engineer. He is the one who that things also comes under plumbing. Not only this, the firefighting. If you deal up with firefighting, if the hazard is not something different, it's a normal hazard, then we'll be using as what? Sprinkler system that is containing with the water or the wet system. So that also comes under plumbing, not the designing part. Okay, I'm talking that piping is also set as a plumbing, piping only. And this chilled water piping is also set as what? Plumbing, or this HVAC chilled water piping, it's also a plumbing piping only. But we don't do the calculation. Why? Because it's not our scope, okay, the calculation. But I'm saying you, plumbing is plumbing. Why? Because we have read plumbing is something, as you said, it's something which supplies the water, or it drains out the water from any service in a wide range of applications. We have seen yesterday, we discussed, like it might be commercial, residential, industrial, whatever it might be. Yes or no? So that's why don't get confused.
Yes.
What is the cooling tower over here? This point has reminded me that's what I can include some chillers, or I can include some firefighting image also. Even that is again consisting, or that again I can say it's a part of plumbing, but not with the technical part. because again, that calculation would be done by a firefighting engineers for that piping and all this. And here the HVAC means HVAC design engineer, okay, or a consultant. Next, let's move on with the water tap. First of all, what is a water tap? We'll be seeing. Under water taps, we do have 2-3 categories. First of all is hose bib. Okay, we'll be seeing under tap. Again, this is a faucet, you can see. And third is again a tap, I think. So first of all, let's see what is a tap and what is a hose bib and what is a faucet. Okay, let's talk first of all with the hose bib. Hose bib is this something which is connected to the inlet of the pipe. This is connected like this with the threadings and all this with the Teflon tip. And here, hose bib is something which has an option to attach the pipe from here. Yeah. Can you see this? A plastic or PVC pipe, plastic category of pipe from where the water can be conveyed to as per their direction they need it. And this hose bibs will be mostly seen on the roof or in the parking area. And this hose bib, main reason to connect it in these areas or for just for the cleaning and maintenance. Am I right? Fahad and Umair. Umair, you have deal with this. Right?
Yes, sir, you are right. Yes. We have installed on the roof.
Yes, for the maintenance and cleaning purpose. For example, if they wanted to do that, okay.
Cleaning purposes.
Yes. So this is hose bib, but the main function of this is different. When a faucet, if I compare with a faucet and a tap, there's a huge difference. What is a tap, anyone? The main difference, tap function is different and faucet function is different. Anyone any idea about the functioning?
Faucet is mixed, used in laboratory.
What is used in laboratory? Oh, okay. Faucet you're saying. Okay, I agree. Faucet is used for laboratories and the tap is not used in the laboratories. Okay, I agree. But I'm talking about the functioning. I'll say you, if you want, you can write it down.
Yes, sir.
Please.
Tap has one type of water cooled, but faucet has both combination.
You mean to say it is a mixer and it can't be a mixer? Is that?
Yes.
I'm talking about the functioning. Functioning refers to, I'll say, a simple thing. We might have observed since our childhood, there was no faucets and there was no huge plumbing as now what has been increased for that, right? I can say one simple thing. Previously, we used to have taps in our houses, yes or no? And we used to tilt it like once, two, thrice. So what do you mean by this? That means if you cut or if you see any kind of tap, I'm saying, or you can say this is a tap. If you are seeing from here, cross-sectional area, if you're rotating 1, 2, 3, you'll be seeing a small kind of gate inside this. So basically, gate valve is installed in the water tank. I'll say you something. For example, if I'm rotating this one time, the gate which is inside, it will slightly lift up and slight amount of water is passing by. Second, somewhat more. Third, somewhat more. Okay. Fourth is the maximum. I'll be getting the maximum amount of water which can be drawn from the tap. Getting my point? And we know that one thing, that gate valve is not an isolating valve. Always remember, if you're dealing with the taps should also be completely open or completely closed. If you try to do isolation with that valves or with that taps, that valve inside that, in short, I can say the gate inside will be getting damaged with the water pressure because it is not designed. Small gate. I don't know how to explain you people. Have anyone an idea what is a gate valve? Have anyone seen visually or physically?
Yes, sir.
Yes, sir. We have installed.
Umair, everyone, no one.
Yes, sir. We installed.
Yes, sir. We have installed.
Yeah,
isolating valves.
Lot of IV, isolating valve. Okay, so that's what. Ball valve is also one more isolating valve. IV. Yes or no?
Yes.
So that's what. The main function of this is, remember, whenever I say the moment tap, whatever it might be, however it looks like, the main function is that we have a gate valve inside, and always remember it should be completely open or completely closed because the velocity which is hitting to that gate, if I'm not opening completely, the gate will be getting damaged. Yes or no? Simple. So this is the function. And this, it makes sense also because if I open once, twice, thrice, I'll be getting at that time the required amount of water, which is helpful for my purpose to serve. Yes or no? If I open once, I'll not be getting very low pressure. So this is water tap. So this is again, hose bib is also having a gate valve inside this. So tap, always remember, gate valve by default inside here. Okay. Next is a faucet. Now just someone said it is used in laboratory. True. Just for the interior purpose. Not only this is faucet with a mixer, I can say. As I just said, on my right hand side, you can see it's a mixer symbol over here. This is my left hand side. This is red. This is my right hand side. So this is my cold water over here. And this is what a strainer you can see over here. And this is chrome coated, I can say. This is, if I tilt this here, I'll be getting, if I tilt complete right, I'll be getting only cold. If I tilt completely hot, I'll be getting on my left hand side completely hot. If I adjust as per my in between right and left, as per what I needed, the temperature of water, I can adjust and I can use it. Okay. And this is a strainer over here, which can be cleaned manually. Okay. Now, the main difference between this and this is what I'll say. If this is not like tap, so this principle works. The faucet works on what principle online? Anyone?
Lever action.
Principle of what?
Lever, yeah, lever action.
No. Lever action in the sense, I did not got what you're trying to say.
While using the tap, you said you have to rotate it 1, 2, or 3 times. But here we can just pull up the lever and pull it down. It will give us the required amount of water.
Oh, yeah, true. What you're saying is true, but technically I'm asking what kind of valve installed inside it. Simple online, I'll say you angle valve. An angle valve is a valve, small kind of valve where you can see below the laboratory. Yes or no?
Yes, sir.
Everyone. Please, man, confirm you guys know this. Angle valve, man, small kind of valve.
Yes, sir.
Come on, man. Okay, the small valve, which you see it over there below, and the same kind of valve is being installed. The mechanism is being there over here. An angle valve is a valve which I can use it as a, it is what? Isolating valve or what?
Isolating valve, sir.
It's not isolating valve. It's what valve? I can adjust the flow as per my requirement. So what is that valve called as? Anyone?
Angle valve, sir.
No.
Angle valve.
Regulatory valve.
Yes, it's a regulating valve. I can regulate the pressure according to my need. Even I need what? More or less, I can regulate it. And this is designed in such a manner that I can use it. If it's half open, full open, or slightly open, does not matter because it can bear that. Yes or no? Angle valve, if you see the cross-sectional area also, you can see kind of angle inside that. Just see this if you have this. Okay, when you're installing, try to rotate or try to on and off and see manually when you're having that in hand. Small device, one angle valve. Okay, just see that. So it can adjust. And the best thing about this angle valve is what? Can I say? Anyone? If I rotate or if I tilt small amount only, I'll be getting a huge amount of water. That is more than enough for us. And this angle valve, same. I mean, the valve which is installed over here will be installed below the laboratories also. And what is the reason behind to install below the laboratory? Because if this faucet or if there's a fitting which is very expensive and it's not having a kind of angle valve, if it is also having, I will be installed one angle valve below the laboratory so that if it's a very huge pressure in the main line or the riser, for example, 30 floors of the building and the water is coming from the 30th floor and we are at ground floor, the pressure you could not imagine. If the main pipe is of 3 inches or 4 inches, what do you people think? As the water comes down, the gravity pressure also catches. Yes or no?
So 10 kg pressure around.
As it comes down, it increases more and more. And we know
10
something. And we know something. What is that? That every fixture demands a certain amount of water, a certain amount of pressure. Not more less than, not more than. If it's more than, that will damage the fixtures or that will damage the fittings. That is not accepted. For example, if I install like Jaguar fitting, it's very expensive. Yes or no? Just I'm saying example. It's very expensive. So in that case, that will be acting as a barrier below. That is angle valve. First it will get damaged, then this will be getting damaged. Okay. So always remember angle valve and how you can see whether this is like installed angle valve or no. Very simple technique I can say you. For example, if you open this, you'll be having, first of all, is a very soft pressure on your hands. Like example, if it's a tap, you put your hand, it will hit on your hand. Yes or no? You can sense some pressure on this, on your hand. Yes or no?
Yes, sir. Yeah.
It's a tap. Here also pressure, but a very smooth pressure. It's not like something which is causing you a harm or something. Okay. Smooth pressure. And most important thing, you will be getting some water bubbles kind of thing, air bubbles, so you can say over there. Okay. Yes or no?
Yes, sir.
Yes.
Smooth pressure and air bubbles over here. You can see this as an angle valve and very smooth pressure. That's the best thing, because if it's a tap, for example, I open in the laboratory, the water will splash out. Yes or no? Here, smooth pressure, it will not splash out. Okay. So angle valve over here. Always remember, most important and the technical thing is this, the difference between this. Wood might be demanding, here it might be demanding cold and hot, but water is again the medium. Here is also water is the medium. But here, gate valve and angle valve. Always remember, completely open or completely closed, not in between, or else the gate will get damaged. This is angle valve, or else I can say this is a regulating valve. You can regulate, or you can, as per your need or as per your demand, you can use this. It's designed in that way. That's why it's called as angle valve. And this is again a tap. What we have seen in previous childhood days or something, the same kind of thing. Now you can visualize the moment I open gate from here, it's lifting, lifting, lifting here. Then from here, the complete water comes. And I need to again rotate. If I have rotated clockwise for 3 times, again, I need to close for anti-clockwise for 3 times. Yes or no? Yes or no? Online.
Yes, yes.
as a circulator pump. Now, you know this, what is a hot water circulating pump. Generally, we do see this small kind of pumps in a boiler system or a central system in a heater, I can say. So in this, what it happens.
Excuse me, sir.
Yes, please.
Sir, I have one question.
Please, please.
For example, if a building has 8 floors and,
Okay.
and the municipal water can provide only for the 4th floors.
Okay.
The rest of the 4 floors, the municipal water pressure is not enough.
Yes.
What we did, we installed one transfer pump, which is providing water at the roof water tank.
Mm-hmm.
And then we install a hydro booster pump to provide or to maintain
Top 3
pressurized water. We cannot provide for the 5 or 6 floors. Is it not possible?
No. Once again, please.
If we
Sir.
will choose a pump with a good head.
Mm-hmm. No.
For the
You can't do that.
No?
Because you just not talked about a transfer pump system. Yes or no?
yeah,
No, Fahad.
I am saying, for example, if I am installing a booster pump in 7th floor building, so
Okay.
can we provide water to all the 7th floors from this booster pump?
Yes, you can.
Yes, main booster.
Main booster. You can do that.
No, I am saying.
I got
my
your question.
is,
I'll say you, Fahad, what you're trying to say. You are saying that why we are using hydro booster and main booster. When main booster is more than enough, what is the need to have a hydro booster? You're saying you want to say that for the top 3 floors. I think this is your question, right?
No, sir. Sir, I am saying, just ignore this situation. Just imagine we have a water reservoir on the roof floor, and the water is flowing by gravity in
Okay.
normal situation.
Yes.
I want to install a booster pump for
Okay.
all floors.
for 7 floors, for all floors. Is it possible?
Hydro booster.
Hydro booster.
We can install a hydro booster pump for
All floors.
to provide pressurized water for 7 floors,
No. No.
right?
No. Wrong.
Top.
Only top 3 floors. See,
Sir, why not?
Just-
Why
just-
not 4? Why we cannot provide for the 6th or 7th floor?
okay.
What is the
Right now, let's
restriction?
not discuss. Right now, not discuss because hydro booster again is a combination with one more system. Okay.
Okay.
Yeah. So that is in that chapter number 6. We'll be seeing what are different types of water entering system into the projects. We'll be seeing over there.
Got
And
it.
it's a combination with one more system.
Okay.
Right now, not disclose it because I've already said you what is a transfer pump and what's a transfer pump system. Again, I'm
Right.
going to repeat you and I'll show you more things in detail, like what is a hydro booster and where it is being used and what is the purpose to have it over there. And what is the main reason to have a hydro booster? Because again, it's been connected with some XYZ system. So where we can't get the pressure, that's why we need again a booster pump over there. And just now we have read booster pump is something just to maintain the pressure or boost up the system, isn't it? So we'll be seeing that in the chapter number 6.
Got it. Okay.
Right. So
Okay,
as of now,
thank you.
let's move on with another pump. It's a small kind of pump. This is called as inline pumps also. That means this is installed in between the lining of the pump. That means in a pipeline, you'll be seeing somewhere nearby to the boiler. And this is called as a circulator pumps. Why I'm calling it a circulator pump? Because it actually forms a loop over here. I mean, the starting and the end point. Like if I rotate this in a 360 degrees, the starting and end point is the same. For example, it just pumps up the water and again brings up the water back. That's why it is a hot water circulation pump. That means it is a circulator. It is circulating water in the main boiler system. And this we'll be seeing only in the boiler or a centralized system, not in the unit water heater, because unit water heater is geyser. So only cold water in, hot water out. But if I talk about a boiler system, cold water in, hot water out, hot water return. Yes or no?
Yes.
So that's what. So that's why the water should be returning back. So this is a circulator over here. So that's the reason we'll be having. And moreover, I can say you why hot water circulator pump is being used. I'll say you in a technical manner. One more thing. For example, if I don't have a circulator over here, if I'm calling for a hot water online, just try to imagine, visualize, unless and until you don't get my point. If then again, still you're not getting, let me know. We'll discuss more in detail. So for example, we are calling for a hot water, any kind of like laboratory or shower. So you might have sensed, I'll give you one simple example. In our home, we don't have this central system. We have this like individual geysers. Yes or no? In our houses. So I'll say one thing that, for example, even though the water is being heated completely and we got a thermostat noise that it's being heated and the power supply has been cut off, For example, if I turn on the hot water supply, I'll not get the immediate hot water. Yes or no? I'll be getting the cold
We need to
water,
wait.
which is already been there in that liquid column of that pipe. Yes or no? First of all,
Yes.
that needs to drain out, and the new fresh hot water comes out at that time, isn't it? Yes or no?
Yes, sir.
Agree,
Yes.
everyone?
Agree.
Right. The same thing happens if we don't have this kind of circulators over here. What happens if it's a long, lengthy, I mean, the central system work like a big heater supplied for multiple bathrooms or the wet areas. So anyone is calling for the hot water, first of all, in that long routing, first of all, that cold water needs to drain out, and the water which is coming from the heater or a boiler, it's been behind that cold water. So first of all, that drains out, then we get this. So what happens over here, if I have the circulator pump over here, so what it takes the water from the pump, I mean the geyser or a boiler. What happens, it pumps up the water, like always it forms like a loop over here. For example, it's always rotating, and here, like example, this circle, in this circle we are having like 1 2 3 4 6 7 8 fixtures connected to them. Like example, you can visualize with a clock like 12 numbers, 1 2 3 4, and all this is a loop over here. So 1 is one fixture, 2 is one fixture, and 12 fixtures, for example. Like anyone is calling for a fixture, what happens, at the very next moment we'll be getting the hot water, because it is always rotating in this direction. Yes or no?
Yes. Yes.
Yes.
But why is it rotating? That is also one question. Again, for example, it started from 1, 2, and again it went to 12. That means it's a boiler over there. And again, it went into the boiler. From the boiler, it's coming out. Again, it's rotating. Why? Why? Because it might be, again, as per the probability. For example, might be chances like all 12 fixtures, no one is calling for the hot water. No one is there in that building. So again, the same amount of water to be returned. Point number 1. Yes or no? Yes or no?
Yes, sir.
Yes.
Second thing,
Yes.
for example, out of 12 fixtures, 4 fixtures or 5 fixtures, 5 people in the building, and they are asking for a hot water, calling for a hot. So what about the rest of the water? It needs to be returned out. So again, by means of some external pressure that is created by a small pump, that is a circulator. So it is pushing the water again back to the heater. Again, it goes into the heater, and new fresh heated water comes out. Yes or no? This is the hot water circulator does. Okay. Don't worry, at the time of project, I'll show you with the schematic diagram, and I'll show you with the line diagram what we have done. We'll be seeing that also. Okay. As if now, just try to get some theory so that becomes easier for you when you understand. Okay. So while you see the diagram, it is used to circulate the hot water in central heater system. A circulator pump is a specific type of pump used to circulate liquids in a closed circuit. Most important, this one. They are commonly found circulating water in central electrical water heaters. Okay. And this is how exactly looks like. This people say as inline pumps. Why inline? Because this is installed in the middle of the pump. I mean the lining or in the loop, it can be installed very nearby to the heater or a boiler. Okay. Inline means it's inline, in between of the line. In between, in the sense, I'm not saying like in between somewhere. That means it's between in the line, in the sense it is installed in the line nearby to the heater. That's why this kind of pumps is called as inline pumps. Within the circuit, this is installed. Okay. Next is a submersible pump. Now again, submersible pump is a pump which is again used to draw water from underground. Like example, bore, this bores what we do have in our houses. So this is a submersible pump. What we do have, this is completely submerged into the water, and this is mostly of stainless steel. And this is a strainer over here. This fits on this. You know this. We have one key over here. I hope you guys have seen this. If you open this, we have one small key, which is kind of a shaft which is connected that rotates this. And you know this, we have number of impellers over here. Yes or no? So that the water turns 1, 2, 3, 4 impellers. And what happens? This rotating energy converts to the pressure energy, and this pressure energy converts to the water. So water, the surface to the above. Yes or no? So this is a starter over here, and this will be again covered with a nylon cloth, so that because they are totally submerged over here, just to protect this, you can see some wrapping over here. It is not wrapped under. You can see there will be some small kind of supports over here, here. This is not completely covered. Inside it's hollow kind of thing. I mean the shaft which is connected to this, and this is completely submerged into the water. That is totally dipped into the water. And here it will be how it will be working. We all know this. Whenever we on this kind of starter, this pump gets on, and what it does, you know this, first of all, this rotates. I mean here it rotates. We are having impellers, a number of impellers. It rotates, then any kind of moving in any direction, I can say, is a kinetic energy, then this kinetic energy into pressure, and that pressure is created on the water. As the number of impellers is more, More pressure, yes or no? Like 1 HP
Yes,
and
sir.
2 HP, point half, like this. So a submersible pump is also called as electrical submersible pump. That means it works on electricity. Is a pump that can be fully submerged into the water. The motor is hermetically sealed and close coupling to the body of the pump. A submersible pump pushes water to the surface by converting rotatory into kinetic and again into pressure energy. That's what it does. Yes or no? This is one more kind of pump what we do use. Now next is a pressure tank. Pressure tank always and mostly with the booster sets, but pressure tank can also be used with the transfer pumps also. If needed, they will be asking, but mostly by default, we'll be having pressure tanks with the booster sets. Why? Because just now we have seen, I've said you just information like main boosters, like example, whenever any kind of fixture is on, the pump needs to on. Yes or no?
Yes.
What do you people think in 6 floors? I'm having 6 floors of the building, and there are like I can say 12 bathrooms. Okay, in each floor there are 2 bathrooms, and there are 12 bathrooms and 6 kitchens. Okay, I mean the wet areas. So, what do people think? How many times, as per your probability or as per your experience, in that building, all 6 floors has been occupied? So, how much times you think pump will be getting on? I can say 100 times in a day. More
Yes.
than that. Yes or no? So what do people think? Is
Yes.
it good enough for a pump? No, because we need to first of all have a pump in series, like 1 or 2 pumps, like one working, one standby, or half of duty. I hope you guys following. Yes, either we need to connect this into series. So, but if I connect to in series also, first of all, I'm investing like 2 pumps. Okay, and second thing, what am I doing? I'm wasting or I'm utilizing the electric power, and that leads to again what online the running cost. Okay, yes or no? And at
Yes.
the
Yes.
same time, the pump might need quick maintenance because it's a working load is more, isn't it? It might need a
Yes.
quick maintenance. I'm saying, for example, it goes for 5 years, or it might get into like only 1 year or 6 months. It needs to regularly check, and it needs for a maintenance might be. So to reduce all this, what happens is over here we connect a booster set with a pressure tank, and pressure tank is a kind of a reservoir, you can say, again in which the water has been filled, and above this pressure tank would be connected with the air compressor, or else directly fitted with an air compressed air over here. So you can see this half is complete air and this is half is complete water. So whenever the pump is being on, first of all the water enters over here. When this the capacity of this holding water has been filled, and you can see a pressure gauge over here, then the water goes like this is like what according to me this discharge, this is suction somewhere. Okay, so this is discharge. Now what does a pressure tank does is, for example, if there is a minor call for a small amount of the use of the water, for example like a laboratory, someone is calling for a laboratory, or someone is calling for a kitchen sink for certain time, because pressure tank do also have a different amount of capacity, starting from 5 liters, 10, 25, 50, 500,000. Yes or no? We have seen this.
Yes. Yes.
Based on different capacities, as per that is being designed on the pump load calculation. So based on this, so what happens is, as I said, this is being connected to a pressure line over that is a compressed line which is already compressing. So this compressed air, it's trying to push this water, but it cannot be pushed because of this thing. You can say this is some external force which is acting on it. But whenever the pump is being off, the water is under pressure over here. That means pressure means it's ready to move, but no one is calling. So example, someone is calling for a minor call of a water. So what happens? This pressure gauge senses and it will not send the pump signal to get on, and it will directly pumps this water from here, I mean from this pressure tank, and serve to that fixture. But if there is a continuous usage of the water, for example 25 liters, it's called for 35 liters, it will go till 15 liters, then it will automatically gives the pump to the signal, and again the pump takes on and it pumps up the water. 5 liters, 10 liters, okay, because it's having a capacity, for example, of 25 liters. Getting my point online? So what is this? We are saving the running cost, and we are increasing the life of the pump, and many things over here, isn't it? We are saving maintenance of the pump also, I can. And only one pump with a pressure tank. Why not 2 pumps in a series? Yes or no? Like one working, one standby, I said you, or a half duty for this, for like 12 on this and 12 on this. Yes or no? This way, once again, the combination of a pressure tank, pressure switch, and these pumps are what allows the water to flow through your home. Pressure tanks, which is act as a reservoir for the home, are generally set to keep the pressure 20 pounds per square inch of your starting and okay, this is Ignore this. What is it and all this? So just a pressure tank is a reservoir for our home, acting for the small call of a water, and that will be giving and not allowing the pump to start on again and again. Okay, because we have discussed is again and again, it makes sense. What are the problems we can face in future with the pumps? Okay, next is what? A dishwasher. So as I said, we'll be discussing it over here. So how this is same dishwasher, the same image over there, how it works and all this. Let's see. The cold water is piped into the machine for your home supply, but I said this works on hot. Outside you only demands hot, but we don't directly give the hot water because we have an inbuilt heater over here inside this. Yes or no? Right. So, but this is the demand of hot water, but we need to supply the cold water first of all. To get that hot water converted into hot, I need to first of all supply the cold water. Yes or no? So
Yes, sir.
cold water is piped into the machine for your home water supply. The heating element at the bottom of the machine, powered by electricity, warms the temperature of the water to 30 to 60 degrees. Okay, that means 60 degrees is standard. Then it warms up, or 86 to 140 degrees centigrade. In between this, it can warm 30 to 60 degrees maximum for the washing of the utensils. An electric pump, so small pump again inside, which pumps up the water from the side walls, and a small jet of water will be sprayed on that. Okay, then it will apply the detergent, and again it will again spray the water so that the utensils get cleaned up. Okay, and after some time we can make use of this, I mean the utensils. So an electrical pump at the bottom of the machine pumps up the water through the side walls. Okay, that means these are the side walls. It is used in the kitchen to clean the utensils with hot water. So it demands hot water. So we need to calculate based on the demand or supply.
Demand, sir.
Very good, demand. Okay, always remember this. Okay, so this is what a electrical water heater, or sorry, electrical dishwasher does. Okay, and that's the reason we'll be having this in the kitchen area, mostly in the kitchen area. It might be used in commercial, residential, whatever, and no need to worry about this kind of pumps and all this, because it is like a complete unit we'll be getting from the manufacturer. Okay, next is a heater. What exactly is a heater? I'll say you. Heater is something in a technical term, I'll say you, just to maintain the demand of the building. Or electrical water heater is device or an equipment which is here to maintain the demand or the hot water demand, I can say. Okay, to meet the demand of the building. Demand of the building in the sense, what demand? Hot water demand. Always remember. Okay, so now accordingly, for example, I need 10 or 15 liters or 30 liters or 50 liters or in gallons, whatever. That is the demand. So it should meet that. So we'll be sizing that heater also, how we need to do that, on what size and all this, how you need to do that. We'll be seeing that when we deal with the heater selection and sizing. Okay, so now just remember, heater is nothing but it might be any kind of heater. It might be unit or boiler. I mean central, it's one and the same. It's just meet the demand of the building, that is hot water demand for the complete building. Now electrical water heater or a geyser or unit water heater, it is used to supply the hot water to one or two bathrooms. So if I talk about an electrical water heater or a geyser or a unit water heater, I can say anything, EWH, electrical water heater, or unit water heater or a geyser. It's one and the same thing. What we do have in our bathrooms, for individual bathrooms, that is nothing but a geyser. Okay, so that is only recommended to have individual bathrooms, I can say. For example, one bathroom, we need to calculate on this bathroom, this number of fixtures should be the capacity of the heater installed into this. Okay, but in worst cases, for example, there are two bathrooms side by side and there is no place over there in the next bathroom. So it can be used for two bathrooms also, but not recommended because it's not a central kind of thing like I can serve to multiple bathrooms. But in case it can be used for maximum of two bathrooms, not more than that. Okay, in that some cases, but not recommended. Okay, and you know this right now in market we are having is like one more small heaters. What is that heaters called as? Small heaters. What is that? 1 or 2 liters heaters.
Instant heaters.
Instant heaters. Now they are using it. Why? Because for example, if you want to perform ablution on all this, it's very quick and it is very instant. Yes or no? Yes or no, online?
Yes, sir.
Right. So that is also one heater. So what we have seen, according to my experience, the maximum capacity of unit water heater or a geyser is 50 liters. Now don't fix this because it might differ from the region to region and it might differ from the manufacturer to manufacturer. And why region to region? Because in some areas, like example in Gulf and all this, there is very extreme temperatures. So again, they might have this nearby to 50 liters and all this. But in India, I can say we are having in our houses not more than 20 or 25. Yes, sir? Anyone from India, basically? Arun, how much you have in your house? 18, 20, 16, how much? 15?
Twenty-five.
Actually, 5 liters, 10 liters, and 15 liters, and 25 liters.
Okay, so 5 liters, 20 liters. Okay, that's so we have discussed is all about some fittings. That is like, first of all, we have discussed the very common thing that is nothing but elbows. So in the elbows, we have 45 degrees and 90 degrees. We have seen both, and white is used. We have checked that also. And we have, after that, we have checked T. In that we do have two kinds of T. And you know, T is something which connects three different pipes over here, isn't it? And one is equal T, another is unequal T. So we have seen this is equal, this is unequal. You can see the shift in diameter. That's why it's an equal T. Okay. Now we're about to start up with this fitting that is nothing but a cross. You can see the shape, it looks like a plus mark or a cross. Okay, that's why it's called as this. And moreover, if you could see over here, there are a number of things like, so there are like, it can be connected to 4 pipes. You can see this might be inlet and this 3 might be outlet, or this might be inlet, this 3 might be outlet. Okay, or 3 inlets and 1 outlet, vice versa. Okay, but this fitting is not recommended. So because you know this is having the maximum pressure drop, or this fitting is having, it's like prepared also. I mean, when it's in manufacture, this manufactured in very high standards. That means it should have a more stress and strain diagram over here, because it will be more stressed than all the fittings. And this causes the maximum pressure drop. You can imagine, for example, if this is one in and this is outlet, this is outlet, this is outlet. So this is a huge turbulency created, and see 3 different ways. So huge pressure drop in it, right? So that's why it's not been recommended to use this. So we don't use this. Okay, but still it's outdated, but still it's being used in some parts, I guess. But I think it's nowadays not used. It's anyone has seen nowadays in any project? No, na? So across, yes, a cross fitting has opening on all 4 of its ends and connect 4 pipes. And cross fittings comes with 3 inlets and 1 outlet, or an outlet, or 3 inlets and 1 inlet, or 1 outlet, vice versa, we said. And as they are connecting points for 4 pipes, they are under more stress than any of the type of the fittings, and typically built tougher than any other fittings, because it's more stressed than any other the fitting in the complete plumbing. So it's built tougher because it needs to bear that much of pressure. Okay, so this is one fitting over here, which we can see. And you can see these internal threads. So this is basically female or a male. We'll be seeing what is that male and female in the future. Okay. Next fitting is nothing but a reducer. So we know this reducer is something we'll be using it. A reducer when we have connect 2 different diameters of the pipe. For example, if I'm having 1 inch of the pipe and I need to, as per the calculation, I got the next part of the pipe which is to be connected to this 1 inch of the pipe. That, as per the calculation we got, is, for example, half inch. So when there is a shift in diameter, I need one fitting that is called as a reducer. So example, just I can say this is 1 inch and this is half inch. So I need this, so that what happens, the shift in diameter and the velocity and the pressure will not decrease. Why? Because you can see the shift in diameter. If the flow is lowering down, what happens? The velocity drops. But again, this much of, the diameter, the velocity will be okay. In short, what I'm trying to say here is, like, where is the shift in diameter? In the line or in the piping, we'll be using this a reducer. Okay. And in this reducer also, we do have 2 different kinds of reducer. One is concentric and one is eccentric. Yes or no? Anyone?
Yes.
This fitting makes a smaller, this fitting makes the flow smaller, and this reduces it. That means when the water or the fluid has been passing by, the fluid is becoming small, or else I can say where there's a shift in diameter in the pipe, as per the routing, as per the calculation, we need to have a reducer over there. Okay. So 2 different pipes can be connected in this on the same axis. So as I said, this is in 2 things. One is concentric and one is eccentric. Now concentric is very commonly seen in the piping. Okay. And that looks in a shape of like this. That is nothing but a cone shape. Yes or no? This is installed in the piping. Okay. Commonly seen. A concentric reducer is used to join the pipe section of the tube sections on the same axis. The concentric reducer is cone shaped and is used when there is a shift in diameter on the between pipes. For example, 1 inch to 3x4 example is given, or you can consider not 3x4, any kind of pipe. Where it doesn't shift in diameter, that is important. where I need a reducer over here. So this is a concentric reducer commonly seen in between the piping. And there is one more reducer, eccentric reducer. But are you people aware what is this eccentric reducer? There's a change in this. You can see this is cone shaped, but here if you see this is straight, and here is slightly not cone shaped, I can say. Yes or no?
Yes.
So where this is used, can anyone has any technical idea where this is being? This is commonly
For
not in
sewer
the-
piping and
Where?
for sewer piping.
Guideline.
No, it's nearby the pump. Yes
I
or no?
recommend it.
Yes, online.
Sir, yes, sir. Sir, especially in chilled water pipe.
Exactly. A chill water pipe or nearby the pumping.
Uh,
Nearby the pump. The reason behind, I'll say you in the suction side, this reducer is being installed. If you see over in the suction side, what happens? For example, if I have this kind of reducer over here and the water has been going, so you can see there's a shift in this. I mean the shape like this. It's not flat. So what happens? Just a minute, please. So what happens? It might create an air bubbles over here, or it might have an air gap first of all. Yes or no?
yeah. Yes,
Second thing is what? Second thing is what? What happens over here? The cavitation will be forming. Okay, to avoid that cavitation and all this because of the air gaps and all this, so we use that kind of reducer over there. You can see, so always in the suction side so that the water goes in this manner. Okay, so this is the thing where we use nearby the pumping system or connected to the pumps. In the suction side, always remember because of this thing, you can see the water touches to this, I mean the surface of this, and there is no gap in between the material and this. So no air gaps and no air bubbles over here. What is air gaps? Inshallah, we'll be coming back for you, Fahad. Okay.
Okay, sir.
Next is what?
Sir,
About the cavitation. Yes, please.
sir, in all kinds of pump, we use a centric reducer at a suction side.
Suction side.
Yes.
Yes.
All kinds of fire pumps and chiller pump and other
No,
pumps.
where there's a shift in diameter, we'll be using this, whatever the pump is. Okay. Where is
Okay.
the suction side? If we are getting, so if there is a, as per the calculation I'm getting, okay, this the manifolds and the suction. For example, the discharge pipe or the suction pipe. You know, first of all, what are the manifolds, which is connected to the pipes or which has been manufactured from the company. I mean, the suction and discharge pipe is called as manifolds, which has been coming from the company. Okay. For example, that and the connecting pipe, for example, is being changed in the diameter. So we need this kind of reducer over there. Okay. So reducer remains same. Whereas in shift in diameter, we need a reducer. Now what? In the line in the between of that, we need is concentric and here eccentric. The main technical thing is this. You can see the shape of this like this. Okay. Now let's move on with the next thing. This is eccentric reducer and that is concentric reducer. But reducer as the main aim just to connect the two different diameters or the shift in diameter where is needed. We'll be having one reducer over there. For example, if you want, I'll give you one simple example also when I go with some more technicality. When I open one line diagram, I'll show you, okay? And I can show you some more fittings. We need to visualize over there. Actually, it's not being shown because it's a single line diagram, okay? We'll be having one reducer or we'll be having one elbow or we'll be having a T. We need to identify this, yes or no? For example, if anyone in estimation, I think they have extracted this, yes or no? Like that, okay? Now, let's move on with this. Now, this is a coupling, okay? What you see, coupling is generally like internal threads. So what do you mean by internal threads? Male or female?
Female, sir.
Female.
Internal thread are female, external thread are male. Okay, so this is basically a female. Okay, and again, coupling is something which is connecting two pipes. Like example, to connect to two pipes, like as is previously, like example, there's like 100 meters of the length, and I can't get 100 meters of a single line or one pipe. Okay, from the manufacturer, what we get as a standard as like 3 meters. Yes or no? 10 feet, isn't it?
Yes.
So now how I need to connect that 10 feet, 10 feet, 10 feet by again some fitting. So this is one fitting which connects the two pipes over here. There's nothing but a coupling, but coupling is a permanent joint, isn't it? For example, if it's like, if I'm dealing with plastic category of pipe, for example, let's say if I'm dealing nowadays, mostly we are dealing with the PVC or the plastic material in the plumbing, isn't it? If it was GI, that was different case. Nowadays is permanently, you can say, or it's being plastic category is totally taken care or take over of the metallic properties now. So mostly in the global worldwide, I can say everyone is preferring plastic category because that is many advantages we'll be seeing in the next chapter. That is the types of materials used in the plumbing. Okay. So now let's talk about the plastic category. So that is CPVC or PVC. or any kind of plastic category of the pipe. So what happens over here, this is like example, we have some kind of adhesives, like we have cement solvent or one glue which is being installed, which is first of all the internal surface of the pipe when it's being attached or cut. It needs to be first of all filed, or it needs to cleaned up, and this fitting needs to be cleaned up with a soft cloth and all this, just to remove the dirt and impurities. And we just apply this kind of a glue or something, like something coats 5W30 and all this kinds of thing. And we do have some cement solvent. I'm just saying this, some kind of solutions over here, what they say. Okay, and they just apply on it and they just fix it. So this is a permanent joint, I can say, not a temporary one. Okay, so this is a more permanent joint. For example, now this can be used in a number of cases. Like I can say, for example, let's take an example. First of all, just remember that this can be used to connect two pipes over here, but this can also be used as a maintenance purpose. For example, in case somewhere the pipe got damaged and all this. So what we're gonna do, just again to connect these two pipes. For example, there was some clog or block we find out, and I'm trying to cut that pipe, and again I need to join the two pipes. So fix it. Again, I'll be using this fitting. Yes or no? Coupling. Yes, Fahad, everyone?
Yes.
So it connects two pipes that have the same diameter and the same type. It is also used to repair a broken or a leak pipe. Okay, so now these are the different materials. Don't fix to the plastic. We do have a GI. We do have like number of, like in plastic category also we do have this fittings over here. Okay. Next is a union. Now union is same like a coupling, I can say. Again, it is also used to connect two pipes. Okay, but this is permanent. This is not permanent. You can see this nut sleeve and all this. So it can be easily installed and uninstalled. That means it can be removed and again put it back. I mean, again, it can be reinstalled. Yes or no? Online?
Yes.
So this is like not a permanent thing, because that was a permanent. Union can have either male or female threads. So this is example, this is female, here it might be male, but still here is also a female. Okay, male or female threads, they are similar to coupling, but the difference is union are easy to remove, making them convenient for maintenance for a planned future replacement. A coupling, on the other hand, is more permanent and needs to cut out. That means it needs to cut out because I don't have any option, because it cannot be, uninstalled. Okay.
Yes.
So now a union contains three parts. One is the nut, male end and female end. It might be male end, it might be female end, and this is the nut what you are seeing. The nut is used to join the male and female ends. By dragging this like clockwise or anti-clockwise, it makes a joint, isn't it? All right. Yes or no, everyone? Please.
Yes, sir.
Right.
Yes.
So this is one more kind of fitting what we can use, what we'll be using. Okay, next is a nipple. What is exactly nipple online? This is exactly how it looks like. So this is having like different varying lengths also. Now, what is this used for, anyone? For what?
For joining two fittings, sir.
Yes, very good. For joining two fittings, very good. Okay, like example, just now we have seen coupling two pipes. Here, nipples to join two fittings over. So not exactly, don't fix this as a short fitting. Now this might be having some varied lengths also. Yes or no? I mean, they'll be having like different lengths also. We can use as per needed. So this is a short fitting that can be made of metals such as copper, brass, steel, and CPVC. Instead of connecting two pipes, a nipple is connecting two fittings. It has a continuous threading. It's a closed nipple. They are usually male and comes on the varying lengths. You can see varying lengths. I mean, the length differs, and this is generally male. So that means it can connect the fitting to a female. Yes or no? Because these are male.
Yes.
Next is a mechanical sleeve. We know this kind of thing, what we have in our general home also. For example, if I have connected any kind of a hose pipe to any of my fitting, like example, I can say hose pipe, I've connected a plastic category of pipe just to transfer water from one place to another as per my need, as it's flexible in nature. So have a, what shall I say, for a secure thing, or not to come out because of the excess pressure, or because of some pressure created while moving the pipe and all that. We having this, we'll generally say as like a clamp over here, isn't it? We tighten this the moment.
Yes, sir. We have clamps to hold the pipes.
The same kind of thing.
Yes.
It's a clamp, but mechanical sleeve is a technical, you can say a word which is being said in our plumbing industry. Okay, a clamp. So what we'll be using, we'll be just putting this, or we'll be just tightening it by a screwdriver. The moment we put this compresses this rubber. I mean this aluminum jacket, what you're seeing, this compresses this rubber, and it compresses the pipe and grabs a tight fit on that, so that it not comes out and all this. The moment we compress or tighten this thing will be coming up, because this is getting compressed, so this will be coming up, and this compresses the internal rubber gasket and all this, so it fixes, or it holds a more grip on the pipe. Okay, Same thing. This connects to pipe through the use of a screw or a device. One more thing I can say, for example, if there is a cutout in all this, we have this kind of thing in our general thing. I'm saying if we get a kind of nipple in a plastic category, also we get. Again, we join. For example, if it's a plastic category of pipe, not the one what we are using, rubber, I can say rubber pipe, what we use. Okay. If there is a leak or something, again, we cut and we install this kind of thing. Yes or no? Plastic, and again, to for a tighter, for example, it's directly connected with the pump, so it will be having so excess pressure. I mean the discharge. Since it is, there is chances certain that it might come out, isn't it? Again, we have a mechanical sleeve fixed on that nipple on the both the sides for here and here. That means when we tighten it so that it doesn't come. You can relate now. This connect two pipes through the use of a screw or the other device. This makes the fitting easy to install. The mechanical sleeve or coupling is used of usually made of rubber that is inserted inside a metal jacket. This is the rubber inside. This is a metal jacket, you can say. I mean the top body. When the clamp is tightened, it compresses the rubber inside to make it. Now, let's move on with the other fitting. And this is nothing but a plug and a cap. You know what is plug and a cap? Or I can say as end dummy or end piece and all that. Okay. But there's a small difference between end cap. Oh, sorry. I can say both as end cap. But what exactly is this plug and a cap? You can see this looks as like a cap, isn't it? And this is a okay. But both are what? Dummy. Right. We use it where we don't need any kind of thing. For example, if I have done with the piping and I have just given the logical connections over there, but I have not constructed anything on some XYZ area in our project. So what I'll be having at that point, I'll be installing this or I'll be fixing this at that point just to not come out the water in that area, because right now there's nothing over here. Whenever I construct this, I've already left the point for it. I can what fix the fixture or I can fix the any kind of thing, whatever is being we are left for or we have calculated for. Yes or no? So this is cap is internal threads and plug is external threads. Okay. We have number of things. Don't fix to this. We have number of things, but just remember cap and thread looks like cap and plug looks like this, and these are all dummies or end caps, you can say. So now let's see. Caps and plugs are both used to close the piping during the inspection and repairs. Just I can say close up the piping openings. During the inspection, not required because it's not exactly, I can say, because that is for the tab work people. Okay, the main difference is the plug is male, as I said, this one, while a cap is a female, this one. Most often, caps and plugs are threaded. Yes, both, that is internal is female, external is male. Plugs and caps are made up of several materials, including metal, plastic, or rubber, can be welded, soldered, glued, and threaded into the pipe. That means there's a number of things over here. As per the material, you need to have the same kind of material installed. For example, plastic, we'll be having a plastic plug also or dummy piece, what we'll be installing over there. Now, example, if it's like leaking and all this, you might or they might or a technical person, not an engineer, a worker and all this, what they can do is they can just have a threading on it if it's like some metallic property, any metal, if it's been installed, or if it's a plastic category, then again, they might go with a Teflon tape and they can fix it for a more leak proof, isn't it? Yes or no, online?
Yes, sir.
So next is adapter. What do you mean by adapter online? This way. Again, one side is female, one side is male. But where and why it is being used? Adapter is the best thing. What? It can turn a male to a, here it can turn a pipe to a female, here it can turn it to male. Yes or no? Two things. Adapter connects two pipes that are not of the same type, because an adapter can male or female on one end. It can turn a pipe to a male or a female. But where is this being used online? What is the use of adapter, anyone? Where adapter has been seen? Where?
Picture.
Picture?
Yeah, picture installation.
Next is why. You asked Vibhad, this is why. We have double Y also. So now this Y is something which is being connected to a vertical pipe or a horizontal pipe to the drain purpose. You can see, for example, if this is a riser and from here the floor drain and all this, the complete water is coming over there. So this is being connected and by means of gravity, the water goes down. So this is one more fitting which converts this, the horizontal flow to the vertical in short. Yes or no? So now build in the shape of Y. You can hear you. Projal, please.
Yes, sir. I think this Y comes under DW.
No. Just fittings we are discussing. Okay? Because again, both are interrelated. The service is drainage, but again, it consisting of water only, right? That is different thing. But you can say this is the technically, okay, this is a drainage fitting. Yes or no?
Yes,
Hmm.
sir.
Yes.
So built in the shape of the letter Y, this fitting is made to connect three pipes, like 1, 2, and 3. Actually, this is only one pipe only, but this piece is something. This is riser, actually, I can say. And here is horizontal, I mean from the floor and all
Yes.
this. So Ys are similar to the T, but with the smoother angles. T is something, T is, isn't it, 90 degree? But what do you think, 45 degree? Yes or no? So less turbulence.
45.
Isn't
Yes.
So Ys are similar to the
Yes.
T's, but with the smoother angle, reduces the friction and turbulence. This fitting is most commonly used to connecting a vertical drain pipe to horizontal, isn't it? Next is,
Yes.
okay, I would like to say there is one more fitting. It's not there over here. Anyone has heard about the bar, B-A-R-B? Like this. This would be in a kind of elbow also. Has anyone seen this? This is again connected to a pipe, and can you see this kind of things? Again, this act as a hose pipe, or where you can connect a rubber pipe over here. You can see this kind of things to have a more grip on this, or else you have one kind of elbow kind of thing also like this, like it will be 90 degrees like this below. Okay, so in short, what is a bar? While saying bar, which
This fitting used, sir, in
PPR you can say, or in GI you can say. As per the material what you are having, we have this. Okay, but the major difference is like the material will differ. If it's like carrying cold water, we'll be having some other, and if we are having hot water, we'll be having some other. Like cold water, that means I can go with the brass, and if it's like with the hot water, I need to go with the copper. Okay, not the plastic material. Okay, so cold water, brass mostly, and hot water, which one? As I said just now, is a copper. Brass and copper. Cold water brass, hot water for the copper. Okay, so you can see this is like something. Now I think you got an idea. For example, if I need to connect my plastic pipe over here, what we get in generally in market, for example, you can see this is having some kind of, when it has been gone into it, it has some, you can see grip on this by means of this. Can you see this online? This thing, and this has been fixed into the line, isn't it? You can see this is threads over here. So this is bar. We get 90 degrees also. If you want, you can just check, because we have seen somewhere like we have 90 degrees also where we can install. Okay, so this is one more fitting. Okay, that is nothing but called as a bar. Now these were about the very first accessory what we are about to see is nothing but a gate valve. So now you know this, what exactly is a gate valve online. A gate valve is something which is not a regulating valve. So what exactly is a gate valve? Yes, Mr.
Sir, please repeat about the adopter. What is adopter? I don't understand.
Okay, we'll discuss that. Don't worry. Okay, I'll give you a more technical. And someone just said me that he's having a drawing. Let it come. I'll show you. Okay, we'll read that.
Okay, sir.
If not, remind me tomorrow. We'll be again, if I try to find out more good stuff so that I can show you, okay, adapters being installed over here. And this is the reason why it is installed. Okay. So now let's move on with the accessories. Very first accessories. And we know this. What are the accessories? Accessory is something where we use, I mean, it's some devices, you can say, where you can regulate the pressure, or you can measure the pressure, or you can measure the temperature. These are all accessories like pressure gauge and thermometer, a number of things over here like valves and all this. These all comes under accessories over here. So we are seeing about the accessories and the pipe and all this. So the most, first of all, we'll be seeing is a gate valve. So gate valve is nothing. We have seen a gate valve again in terms of tap. The same kind of valve is being installed in the tap, and faucet angle valve. I hope you guys remember. So this is how exactly a gate valve looks like. For example, this is a cylinder, or this is a sphere or wheel, you can say. When I rotate in clockwise or anti-clockwise, for example, as if now according to my side, if I rotate this in anti-clockwise like this, okay, this will be lifting up. And if I see from here, so I'm having a small gate or a welded sheet over here, small sheet or a welded gate kind of thing over here. It lifts slightly. And from here, for example, this is the inlet and this is the outlet of the water. So the water goes and moves on over here. For example, this is the most important thing whenever we are having a gate valve or IV. I can say IVs are like ball valves and one more IV. Why IV? Isolating valve. That is, it should be All IVs should be completely open or completely closed. Isolating valve. It is isolated. Yes or no? Not a regulating. Right.
Yes, sir.
Gate valve is a valve which is being utilized, a valve utilizing a gate, usually wedge shaped, that allows the fluid when the gate is lifted from the. Always remember, this would be again used for the maintenance purpose, and you find this most when where nearby to the tank. For example, if I'm having a roof tank over, and if I need to cut down the complete water supply just for the maintenance for the complete building, I'll be having one valve over there. Yes or no?
Sir, even inside
Or
the
else-
toilet, sir,
or
even
else,
inside.
or else I can say, for example, nowadays in modern plumbing, what they are doing, individual bath in the riser,
Yes,
you
sir.
are having one valve over there. That is a ball valve, I can say, or a gate valve. Okay, why? Because, for example, it's not recommended. For example, if it's a high-rise building and it consists of like 10 bathrooms and like 10 kitchen areas, for example, in that building, it's not recommended that I totally disconnect the complete water supply just for one person who's suffering, right? So that would be open from the top. Here I'll be closing it. That means no water supply in this particular wet area, so that we can proceed with our work, isn't it? Yes or no? So different risers for this line.
Yes, sir.
So likewise. So as you said just now, so we can see, if you observe this, you'll be seeing different valves nearby to the toilet. That means I can cut down the water supply in this area and we can go for the maintenance. So always remember, this will be always open whenever we need it. When that only at that time only we'll be closing this, isn't it? So completely open and completely closed. But if I try to lift or like half open and half closed, if I have done that, you know this, because it's not a regulating valve, it cannot bear that much of pressure. The gate inside this will be damaged because of the excess pressure. It is not having this capacity or tendency to bear that much of pressure. But when compared to ball valve is somewhat higher when compared to this, because it's having a cross section kind of C kind of thing over there, or what shall I say, a kind of scoop. You have seen online scoop. What is a scoop? Where we carry ice cream, where we try to take the ice cream. For example, if I'm having a brick over there, how we take ice cream in a scoop, right? So how exactly it looks like, it's kind of same thing, ball valve. So it can be partially open or partially closed, but not recommended. But because of gate valve, like this flat surface, directly hitting, damaging. But as per this curvature, I mean the curve over here, we'll be having somewhat regulative attacks, but not again recommended. That why they are using nowadays, because the life of this is, when compared with that, is more. So that's why nowadays ball valve we are using rather than gate valve. Both are IVs only. So now we are using ball valve. So, but the thing is, both are IVs, isolating valves. So no, this was about the gate valve. So gate valve has less resistance to the flow and should always be fully open or fully closed purpose. Now globe valve, where do you see globe valve online? For the higher flows. Yes or no? And anyone has seen Swadesh, they can identify. No one has seen?
Yes, sir.
Swadesh movie, man. Right there. So this is a globe valve where you can regulate. It's a regulating valve for a higher flow. For example, this inlet and this is the outlet. So water comes like this. Again, same function, but for the bigger flows, when I open or anti-clockwise, if I rotate this will be coming up, and it allows the water, for example, like this and going like this. Okay. So I can adjust or regulate the flow as per my needed. And if you remember, they check on the other side that how much pressure it's been required. For example, they were generating electricity. So as per the need or as per my the pressure required in the line, I can adjust. That's a regulating valve, isn't it? So this is used for the higher flows or the bigger flows, and this. So this is a globe valve over here. So globe valve is different from a ball valve. It is a type of a valve used for regulating flow in the pipeline, consisting of a movable disc type element and a stationary ring, and seated in a general spherical body. This is commonly seen. Do you use this in plumbing or HVAC mostly?
HVAC, sir.
In firefighting, no?
In firefighting, I can't see, but in HVAC.
Yes, for the higher flows. Okay. Next is the angle valve. Now this is the same valve which has been, you can see, or the principle in this is what, where you see below the laboratory, and this is again the same valve is being installed in the faucet, what we have discussed. Yes or no? For example, if I slightly tilt, I'll be getting the pressure required or more than enough for me to serve the purpose. And why we are using one more thing is that just to what online? Save the picture. I mean the faucet over there. Because example, if you think, for example, the water is coming from like 30 feet or 40 feet of the height and it's hitting to that laboratory. For example, if someone is calling, so that faucet might be damaged or that fitting might be damaged. Yes or no?
Yes, sir.
So we are regulating the pressure for that faucet from here, isn't it? So first this will be getting damaged and that faucet, because that is much expensive when compared with this. Yes or no?
Yes, sir.
So this is
even with Muslim showers.
Which one?
Even with Muslim showers, we always use the angle valve.
Muslim shower?
Yes, which is used with the WW.
No, I didn't.
Yes, sir.
Hand shower.
Familiar.
Hand
Even
shower.
hand shower, you can see.
Yes, yes, yes.
Yes.
Yes. Okay.
Linear.
Manually operated valve with its outlet opening oriented at right angles to its inlet opening, used to regulate the flow of a fluid in a pipe. As you know this as a regulation valve, angle valve. Now PRV, this is very important, pressure reducing valve. So now let's see what exactly PRV stands for. That's a pressure reducing valve. The name itself is saying that it is a valve which reduces the pressure. But how? Whenever the fluid flows by this or passes by this kind of valve, the pressure it reduces. How and why this is being used? As per the standards like IPC and UPC, first of all, they says this, and where we'll be seeing this pressure reducing valve is in the risers. Okay, for example, I'm having like 30 floors of the building, just an example, and the water is coming from the 30 floors of the top of the building and it's coming down, and I'm having all that's completely residential, you can say. And on every floor, we are having like wet areas like bathroom and the kitchen areas. But the problem occurs when the pressure is coming down, it increases more and more. So as per the standards or as per the codes like IPC and UPC, they say that it should not increase more than 80 psi and it should not increase more than 60 psi. So 80 psi is being set by IPC and 60 psi is being set by UPC. So now whatever the standard your company is calling, whether IPC or UPC, you need to check in the riser, in a vertical pipe in short, whether the water which is coming down, it should not exceed. For example, on the 30th floor, if I came across 29th or sorry, from the 30th floor, the water is coming down. And if I check on the 30th floor to 25th or 24th floor, I got there is like 90 psi. So I need to check before that floor. For example, I've checked on 27th floor. Okay. And I got, okay, here is like 59. For example, if I'm dealing with UPC, so I need to install one PRV over there so that the water becomes zero over there. Again, it what happens? It crushes the energy over there. I mean, it's a kind of plunger over there. I mean, a kind of, what should I say, spring over there, which comes and it balances and it tries to break the velocity over there or the gravity pressure. Then again, it starts from zero. So we need to measure this where I'm getting 60 and 80 psi as per the standard. So there are different standards, different values over there. So mostly is 80 and 60 as per, because mostly used is IPC and UPC. So we need to check this and we need to install one PRV in the riser. The reason behind to install it over here, because there will be no excess pressure. They says that the UPC and IPC, the codes, the standard value, why they're saying this, it is being sensed by them that if the value does not increase as more than 60 and 80 psi in that particular height, in that particular floors for that, so that is sufficient enough or that is more than enough, or it's not excess pressure that will be damaging the fixtures. Getting my point online? Yes or no?
Yes, sir. Yes, sir.
Right. So that's the reason we are cutting it down, the pressure which might cause a problem in future to the fixtures, we are cutting it over there. But still we have some precautions. For example, angle valves and all this, just now we have said you, I mean the laboratory. Yes, please.
Sir, I have one question. Sir, if the building height is 137 meter, so how many PRV we can install?
Is building height is?
137 meter.
We'll do it now. Okay, don't worry. No,
Okay.
I have one example. We'll be doing it now. Okay.
Sir, can you please tell me again this pressure values?
Yeah, it's there, Fahad. Don't worry, it's there below. Okay. Following Fahad.
Okay. Okay.
Right.
Sir,
So it is used
what
to
does it mean? 80 psi.
pressure, pounds per square inch. We'll be seeing one example. We'll be seeing one example now.
I mean, yeah. Okay. Yeah.
It is used to reduce the pressure in order to maintain the life of the pipe. So, as I said, velocity plays a major important role in a plumbing, because if you deal up with different types of flows, we'll be seeing that also. We do have two types of flows. One is turbulent and one is laminar, right?
Laminar.
So laminar is what smoother, turbulent is what with high velocity. So high velocity with the bigger diameters of pipe, not recommended. We have maximums, laminar or turbulent, we'll be seeing that. So if the velocity inside the pipe is higher, what happens? We know this, the life of the pipe or the material will be getting reduced for sure, isn't it? Yes or no?
Yes,
Yeah.
Now, this valve reduces the pressure of the water that goes through it or passes through it, you can say, and is used to obtain a regulated and constant value at its outlets. That means I can say, yes, we have regulated the value and it's within the range. So I'm not having any problem. I can say yes, constant in the sense it is within the standard. Like either if I'm dealing with 80 or 60, like IPC or UPC, I am pretty sure because we have done the calculation. We have fixed one PRV over here because I've calculated, okay, here is 60 and here is 80. As per that I have done. So I'm pretty sure in this particular length of this pipe in this vertical, here in between this is 60 or 80. So I can say it is within the standard, not constant, you can say within the standard over here. It is installed at the water means, that is the rises for the high-rise buildings. So this is used in the high-rise buildings, and water means, that means in the rises it's been installed. It protects the whole installation problems due to excess pressure, which is causing pressure noises in the pipes. That means noises in the pipes. Have you heard? No? Anyone?
Yes, sir.
This pressure will be causing noises in the pipes, then water hammer, then splashes. What is this water hammering? What is splash and all this? We'll be seeing it now. Okay, for example, this is pressure reducing valve. You can see the strainer and all this. For example, the water enters. You can see this inlet and outlet. It goes over your strainer and it compresses over. You can see this. This try to compress the spring, and again, what happens? The pressure tries to minimize or minimal, then it will be going down. Okay, so what is happening whenever the water has been passing by? What is happening? It is reducing the pressure, isn't it? Then it is neutralizing, then it is allowing. Okay, so this is how exactly a pressure reducing valve look like, and why and how it is being installed as per the calculation. We'll be seeing it now, inshallah. So always remember, if you're dealing with IPC standard, you need to check where you are getting the pressure in the line as 80 psi, and as per UPC, you need to check where you are getting the pressure as 60 psi. You need to install one PRV, or you need to show in the line diagram, okay, here we need one PRV over there. Okay, now for this, have you people heard in plumbing, firefighting, pressure exerted at the bottom, one liquid column of height? Anyone? Have you people read in the firefighting that what is the pressure exerted at the bottom in one liquid column of height? Anyone? Has sir, you people reached over there or no? Pressure exerted at the bottom, P is equals to
Rho GH
0.433 psi, H into 0.433 psi.
into height.
No. Okay, don't worry. If not getting, it will delay. It will not rush. Okay, we'll discuss that. For example, everyone, just see it over here. There are a number of things over here. Okay, so now let's see this project over here. So let's read first of all this project. So this is basement 2, basement 1, ground floor, first, second, and then so on. This is 14th floor over here, 13 and 14. Then still it's continuing the same, 14 and 15 and so on. And I'm having this like 30 floors of the building, and I'm on upper roof. I'm having this one tank over here. So now if you see this, there is one water line coming down. This is called as a gravity line, what you're seeing. Okay, this is a gravity line. Why I can say gravity line? If you can see this connected to this header to the tank, and it's coming down. And you can see this has been serving to this, what line? One line? The branch coming out and serving on this floor and so on. Now this is what a PRV looks like, the same kind of spring and all this. So this is the pressure reducing valve. So now how it works, we have seen. Now why they have installed it over here. So now, for example, this project for some XYZ Gulf country. So now let's see why they have installed over there, and let's find out that whether they are dealing with IPC or UPC. So I need to find out at the point here, like example, this midpoint, what is the pressure acting over here? Because there might be pressure acting, like example, this much of pressure. For example, as the water coming from here, as it comes down, the gravity pressure increases.
Yes,
The more it's coming down, it increases more and more. So what do people think? For example, this 30 floors of the building, if I'm supplying till this floor, like ground floor or first floor. So what do people think? The pressure will be increasing 60 psi or 80 psi or more than that? Very huge, isn't
More
it?
than that.
More than that, right? So you can
Yes.
see there are n number of PRVs. Okay, here,
Yes.
Umair, follow. Your doubt will be clarified over here. Okay, so there's one more PRV over here. Okay, and further one more PRA, one more PRV. I'm not having any PRVs over here because I'm not getting the pressure what is required. For example, required in the sense I'm trying to say that is within the range. If it is exceeding more than the range or as per the standard, what code we are following, again, I need to install one PRV over there. So now I need to find out the pressure exerted at the bottom.
Yeah.
That means what is the pressure acting over here. So what is the reason they have installed one PRV, that is the pressure reducing valve. So if I try to find out this, then I can say this. If I'm getting the value nearby 60, I can say this. They are dealing with UPC, or if the value is getting by the nearby to 80, then I can say it's a IPC, isn't it? And if you want this reference, I can give you also, but I'm not remembering. I have this code with me. If you want reference, like it's been clearly mentioned in the code. Just a minute. If you want reference online, do you or no? I'll give it tomorrow. Exactly. I'll find out. I'm not remembering.
No problem.
This or some code, but we are having it clearly mentioned, because you can say that if someone is asking, yes, it's been given from this code and it's been clearly this, for example, this table number and the chart or whatever. We can say the code and page number, so they can find out with the year and all this, just for the information and reference. Because I said, nah, anything is something we don't just say it. We need to just check and say that, okay, yes, this is again used for, I mean, we need to give some kind of references also, so that they accept, or else they don't. Okay, let me just read it over here. I think here it's inside. This is fixture estimated demand. Okay, nothing. If you read it over here, assume an office building of 4 stories and basement. Pressure on the building side of the pressure reducing valve of 55, that is PSI, after allowance of reduced pressure fall off at peak demand. An elevation of height above, an elevation of highest fixture above the pressure reducing valve of 45 feet, a developed length of the fixture. Okay, not exactly it's saying, but I have it. I'm having it somewhere. Inshallah, I'll try to find it and let you know, inshallah, in tomorrow's session. Okay, everyone. So as of now, just to remember, pressure to find out the pressure exerted over here, we're having a formula. Pressure exerted at the bottom of one liquid column of height, that is P equals H into 0.433 PSI, where P is nothing but the pressure, what we are here to find out, and H is nothing but the height, okay, equals in terms of feet, and 0.433 PSI is the standard, or standard you can say, and that the units is PSI. That means where I can find out the thing in terms of PSI. So first of all, I need to find out the distance over here, or the height or the length over here. Then I need to put into that. But there is some conversions, because here these things are in metric, that is millimeters I need to get. So I need to convert that into feet, then into what? Yes or no? Okay. For example, DI. First of all, you people write it. P is equals to H into 0.433 PSI. That is pressure. To find out the pressure exerted. If you're not getting, I'll say you one simple example online. Just see this. There's a water bottle in my hand. Okay. For example, if this is completely filled, here will be the most acting pressure, isn't it? Because this complete load is over here, isn't it? Yes or no? This base. Yes or no? Online.
Yes.
I'm here to find out what is the pressure exerted, or what is the pressure acting over here in terms of PSI. If it's like 80 or 60, again, this bottle is further continuing. For example, here, I need to install one PRV over here, so that it becomes 0. And again, if it's like 80 over here or 60, again, I need to install one PRV over here. To find out the pressure exerted at the bottom of one liquid column of height, the formula is P is equals to H into 0.433 PSI, where H is nothing but the height, okay, and 0.433. Sorry?
Sir, P is equal to H?
P is equals to H into 0.433 PSI.
0.443 PSI.
0.433.